if you see this particular two courses 2 and 3, for this particular two courses there are no course materials over here. Okay, so now this is something that we can take care of, right? Because ideally what we can do is when you define a course, you should save a course material with it, right? Without a course material, you should not be allowed to save a particular course over here. But currently you can see that we were allowed, right? We were able to save this particular thing. So how to do that? So that is optionality. Optionality means it defines that whatever the relationship is, that it's an optional relationship or a mandatory relationship. So it defines. Currently you can see that by default everything is optional. Okay, there is nothing that is telling us that this is mandatory. Currently when we save the course without adding the course material as well, we were able to save it. So let's see that. So if you go back to our course and course material over here, so if you go back to the course and course material, here with this particular one-to-one relationship, I can define optional equals to false. By default it's always true. So now I have defined over here that whenever you are trying to save a course material is required. It's not optional over here. So let's go back to the course material repository test and let's try to save the course over here. And we already have one save course material. Let's use the same thing over here. Okay, what I'll do, I will not define the course over here. Okay, and I'll just change the material as, let's say, daily code buffer. Okay, and let me save this. Let me try to save this. And here you can see that we got the error over here. And here you can see that what it is asking here is data integrity violation exception, non-null property reference a null or transient value over here for this particular course. So that means this is forcing us to add the course over here. Okay, so now if I, let me just change the name over here. Okay, I'll just say .NET. Okay, now if I add this particular course back, okay, for this particular course material, then only it will run now. See, here you can see that it is successful, right? You can see it was updated. Now if I go back to the MySQL and go to the course, you can see that new course was added, .NET. Okay, and if you go to the course material was added for it. So this way you can define the optionality for your entities that you have created, which of the particulars entities or which of the particular objects and classes are optional or not. Now let's go back to the one-to-many relationship. Here for this particular teacher repository, teacher class, we have defined that teacher contains a list of courses available. That's a one-to-many relationship. Now what will be many-to-one relationship? Many-to-one relationship would be there are many courses available and those particular courses are being taught by any one of a teacher. So rather than defining this way, like this particular class, this particular teacher have a list of course, we can define a particular teacher who is teaching a particular course that we define. That is more readable, more understandable, and that's a guidance provided by a specification of JPA that you should always go for many-to-one relationship whenever possible. So what I'll do, I'll just comment it out for now over here. Okay, I'll just keep this in the code as well so you can refer it out. So what I will do, rather than defining this way, I will go to the course over here, and for this particular course I will define that this particular course is taught by whom. So I'll just say private teacher, and this is many-to-one relationship. Okay, we just reverse it, one to many, this is many-to-one. Now here also we have to define the join columns over here. We can define the name of the join column and also define the reference column name over here. The reference column name would be inside the teacher, this will be teacher ID. Okay, that would be reference, and we'll define with same teacher ID. Now with this particular chain, there won't be any change in your database. Everything will remain the same. This is how you represent all your tables in your objects. That's a representation change over here, but the structure will remain the same. And this is still many-to-one unidirectional relationship. Now when we are trying to, now here as well, in many to one relationship, whatever you define in over here, you can define cascade type all over here. So whenever you are saving a new course with a new teacher and a new course material, all the things will be saved or all the things will be deleted, whatever is preferable. Okay, now let's create a course with all the particular values. Okay, so I'll go to the course repository test over here. I'll say public void save course with teacher object. Okay, I'll annotate with @test over here, and what I'll define over here is course object course equals to course dot builder dot, what's the title of the course? I will just say Python dot credit is 6 and dot, you can define the course material as well. Let's define the teacher, and for this particular teacher, what I can do, I can create the teacher object teacher equals to teacher dot builder dot build dot first name, I'll just say Priyanka dot last name Singh dot build. Okay, this is the teacher. Now this particular teacher I'll pass to this particular course, that this particular Python course is taught by Priyanka Singh, and now I can directly say course repository dot save this course over here. Here you can see that I'm just doing the save over here. It applies to update, delete, get all data, get a particular data. For everything this applies. Okay, I'm just giving you a very simple implementation over here so you can understand. Now let's run this. So what should happen over here is a new teacher should be created, a new course should be created, and for that a foreign key of a teacher should be assigned to a course. So let's run this. And here you can see that there is an error over here. That's fine. I'll just comment it out over here for now. Okay, because we just removed the reference of the courses over here. So let's do this, save courses with teacher again. Here you can see that the course is created and a teacher is created. Okay, so let's go back. Let's go to the teacher table, and here you can see that new teacher is created, that is Priyanka Singh with teacher ID 2. And if you go to the courses and if you run the query, you can see that new course Python is created and taught by teacher ID 2 over here. Simple thing, one to many and many to one relationship. Now let's see how to implement paging and sorting using JPA repositories. Now as you are already aware that for every repositories we have implemented the JPA repository, and this JPA repository again extends the paging and sorting repository. If you go to this paging and sorting repository, you can see that either you can implement the find all method or find all method based on the sorting or based on the pagination. You can implement the pagination and it will return the page object with the particular data type that you are passing, particular type of object, and that will take the pageable as the input parameter, where you will define the different page number and how many records that you want for that particular page. And for the sorting as well, that you can define what kind of sorting that you need to implement for fetching the data. So let's go ahead and see how to use this particular default methods and how we can implement the custom method as well. So let me just close this, and for this particular course repository, let's go to the test over here and let's call this particular method. Okay, so let me just create a new method over here. Okay, I'll just say public void find all pagination, and I'll just do @test over here, and here I'll define the pageable objects, and I just say pageable first page with three records equals to page request dot off method. Here you can see that this particular method takes the page number, the size of the page, and the sorting for that particular page. So I'll just define the 0th page, that is the first page, and I want 3 records over here. So I'll just remove this I'll just remove this as well. Let me create one more object of pageable. I'll say second page with 2 records equals to page request dot off. I'll say second page, that is first, and I want 2 records. I just created this particular object over here. Now I need the list of courses available for this. So I'll just say list of courses available equals to course repository dot find all, and inside this find all I'll just pass first page with 3 records and dot get content. So this is a simple method that I am using find all, where I'm passing the pageable object that you saw over here. Okay, you can see that it is taking the pageable object over here as an input parameter from the paging and sorting repository. Okay, so I'm just using that particular inbuilt method over here, where I will just define the 2 pageable, first page with 3 records, second page with 2 records over here. First page, that is 0th page, 3 records that I have defined 3 over here. And this particular object will return the page of courses. From that particular page of courses, I have used .getContent method to get all the contents of that particular page. Now there are more details also available. We can get the different things such as total pages and total elements as well. So let's do that as well. What I'll do, I can define long total elements equals to dot. Here you can see that there are a lot of different methods available. Dot get total elements, you can convert to stream as well. Okay, you can get the contents, you can get the number of elements, you can get the total pages. Okay, all those things you can do over here. So let me just get the total elements over here for now, then I can have total pages as well. Okay, I can say long total pages equals to course repository dot find all first page with 3 records dot get total pages. Okay, and I can define this particular total pages as well. And if you go to the database, currently I have 5 records available. Now let's run this. You can see that there are a lot of queries available. Okay, these all the queries were executed, and you can see that there were a total of 2 pages and the total elements are 5. Why there are 2 pages? Because I have defined that my page should be of 3 records. Every page should be of 3 records. Okay, so that's why I divided into 2 pages, and I want the first page. So first page should contain 3 records. So here you can see that first course, second course, and this is the last third course available. So 3 courses are defined over here. Now if I pass the second value, second page with 2 records everywhere, and if I run it again, I should be getting 3 pages, because each and every page should be of 2 records. Okay, here you can see that I'm getting total pages as 3. My total elements are 5, and as I need to have the second page, I will be getting the 2 records of the second page over here. Okay, so this way you can implement the by default find all function using this particular pagination as well. Okay, now let's implement pagination with sorting. I'll just create one more method, public void find all with sorting. Also, this is a test over here. Suppose I want to sort the data based on the title. Okay, so what I can do is I can use pageable sort by title over here, page request dot off. I can say 0th page with 2 records, and sort dot by, I can say title. Okay, simple page request just like over here whatever defined over here, but here I just added the sorting as well. I can also do pageable sort by credit descending order as well. I can do page request dot off first page with 2 elements dot sort dot by credit dot descending. So this will sort the records by credit in the descending order. I can also define pageable sort by title and credit descending order. Okay, for this I can do page request dot off, can do first page with 2 records where I can define sort dot by title and descending order dot end, again do sort by credit. Simple, right? And now I can pass everything over here. I can do list of courses over here equals to course repository dot find all, and inside this find all I can pass anything. I'll just say pass sort by title over here dot get content, and let's print it out. Okay, and we can run this. So here I just gave you the different ideas like how we can use this particular different sorting, multiple sorting, descending order, ascending order. Okay, and we can pass that particular page request to our find all method and we can get the data over here. So let's run this, and here you can see that we are getting the data over here. Now we can create the custom method as well for the sorting. Okay, so what we can do over here, we can go to the course repository. Okay, let's create the method over here. What we can do, list of courses over here. Okay, and for this particular list of courses, what I need, find by title, find by title containing, find by title containing over here, and here we need to pass the string title over here and page request. So this will convert all your data to the list, but here you need a page over here. Okay, that you should be getting the page. So whatever the page request that you pass over here, you will be getting the data as a page object over here. So let's check this as well. So we will just call this. Okay, we'll create a new method, public void print find by title containing, and I'll just use test over here. Here I'll just say pageable, again first page 10 records. Okay, equals to page request dot off first page and 10 records over here. Now what I need a list of students, sorry, list of courses equals to course repository dot find by title containing, I'll say containing D, and first page 10 records over here, and here I'll say dot get content. Okay, I did one mistake over here, this should be pageable. Okay, right, now let's go back over here, and here you can see that the error is resolved. Now let's print it out. Okay, I'm printing the list of courses available with the first 10 records of the first page, and we are just getting the title who's containing capital D. So if I go over here, how many capital D, how many records you should get is DSA and DBA over here. So let's go back and run this over here, and here you can see that we got the records. Okay, we got DSA and we got DBA, nothing else. Okay, So my method is working perfectly fine. So this way you can go ahead and implement paging and sorting using JPA repositories. Now let's implement many-to-many relationship. So with this particular image, we implemented course and course material, that is one-to-one relationship, teacher and course, that is many-to-one and one-to-many relationship. The last one is student and course. The student and course have many-to-many relationship. Many student can opt for many courses available over here. So we already have a student class and a course class over here. Now we have to implement the many-to-many relationship. How many-to-many relationship works is, we already have a student class, we already have a course class over here. Okay, two classes are already created. Now when you implement a many-to-many relationship, there has to be a third new table added to it that represents the mapping between the two tables, that is a student and course. You have a student, you have a course, and there will be a third table that represents this particular student ID to this particular course ID. So multiple student can have multiple course ID. So that particular table will hold the relationship between the two entities that we have. Okay, so there is a third table, new table will be introduced for many-to-many relationship. In the earlier, in one-to-one and one-to-many or many-to-one relationship, there are only two tables associated always and a foreign key was assigned. But here, third table will be introduced over here. So let's go ahead and implement that. We'll go to the IntelliJ IDEA and we go to the courses over here. This particular course is, here we need to add the many-to-many relationship. We already added one-to-one, many-to-one relationship. Here we need to add the other relationship, many-to-many, for the students that we have. As a particular course can be opted by multiple students, so we need to have a list of students available over here, right? So I'll just define private list of students available over here. Now for this particular, we need to define many-to-many mapping over here. Now as for this particular many-to-many relationship, as I told that there has to be new table created, we need to use the join table annotation over here. You can see earlier we used to just use join column annotation. Here we will use join table. So I'll just use join table annotation over here. And in this particular join table annotation, we need to define what will be the join table, what will be the new table, and which two particular column that we are going to refer over here. So let's add those information. So here I'll just define what will be the name of a table. So I'll just say student course mapping over here. And here I'll define what will the join column equals to @join column over here. And for this I need to define what will the name and what would be the reference column name over here. So what I need to refer to what for this particular student, I need to refer to the course ID. Okay, so whatever the course ID is available over here, that would be the reference column. And what would be the name of the column that I want to define, that is course_ID. Okay, this would be your database, what you want to define, and this would be your class property that you have already defined over here. Now this is the joining column that you have defined for your student, that is your student will be having the courses. Now you need to define the inverse join column as well, that for your courses what should be for the student. So I'll just define inverse join column equals to @join column. What would be the name? What would be the reference column name? And this would be for your students. So if you go to the students, this student ID would be your reference column name over here. And your table name, your column name should be student ID. Okay, so what we defined over here, that for this particular course and for this particular students that we have, we are creating a new table that is called student_course_map, that will have two columns, that is course ID and the other is student ID. This course ID will refer to the course ID of this particular class, and inverse column join, okay, that is whatever I need to define for this student over here. Okay, so whatever you defined over here, the list available for many-to-many mapping, that would be for your inverse join columns. Okay, so I need my column name is a student underscore ID, and it refers to the student ID of this particular class that I have defined over here. It's really simple to understand, just it looks complicated. Okay, it's really simple. You just define the new table that contains the mapping between the two already created table for many-to-many mapping. That is a student and a course you have, and as multiple students can opt for multiple courses, you need to normalize those tables to remove the redundancy, and for that you created a new table. That new table contains the mapping between your course and a student. Simple. So this is the definition that we have provided for many-to-many mapping. That's it. As is a list of students, I already told you earlier as well. When you are working with a list, you can create one more method to add the letter to that particular list. So let me just create a method. I'll just say public add students. Okay, this will take student object, and if students equal to null, students equals to new array list. Okay, else directly I can say students dot add student. Now let's go ahead and test this particular thing out. Okay, let me start the particular application. Okay, and here you can see that if you see create table, student course map is created where we have two different IDs, that is a course ID and a student ID, two columns available, and it refers to the two different foreign keys. That is a student course map refers to the foreign key of a student ID and a course ID over here. And if you go to the database, if you refresh it over here, you can see that student course map is created over here. So let's try this out. So in the course repository test over here, course repository test over here, let's implement one method. Okay, public save. What we'll try to do is we will try to save a course with a student available. Okay, save course with student and teacher. Public void @test course equals to course dot builder dot build dot course title. What's the course title? I'll just say AI dot credit. What would be the credit? I'll just say 12. Okay, dot I need to add the teacher as well. So suppose I already have a teacher, or let's create a new teacher as well. So I'll just say teacher equals to teacher dot builder dot build teacher first name Lizzie dot last name Morgan. This is the teacher. Now let's add the students as well. Okay, here I can add the students. Okay, so what I can do, let's create a student as well. Student equals to student dot builder dot build dot first name Abhishek, last name Singh dot email abhishek@gmail.com. Do I need to add guardian? If I don't add, that's fine. I don't want to add it now. This is the student. I can add multiple student as well, but let's add one student only. Okay, so I just added the student as well. So I just created my entire course object. Let's do course repository dot save course as well. So we just created teacher, student, and we just added all the details in our course as well. So let's run this out. Let's see what's happening over here. Okay, and there is an error. That's good. You can see that invalid data access API uses exception, right? Because you can see that transient object exception is there. Why? Because we added the student over here and we have not defined the cascading type. Okay, so let's go back to the course over here, and for this particular students in many-to-many mapping, we can define the cascade type as cascade type.all for now. Now let's go back and let's run this again. Yeah, you can see that it is successful. Okay, and if you come over here, you can see that there is an insert into teacher, insert into course, insert into student as well, and insert into course student map as well. Okay, so let's go and check our records as well. So we added the new course, right? So this is a new course, that is AI. Okay, this AI has been taught by who? Teacher ID 4. So if you go to the teachers, and teacher ID 4 is Lizzie Morgan, that is ID 4. Now which particular student, right? If you go to the student as well, a new student was added, that is Abhishek. Okay, now if you go to the student course map over here, there will be mapping which particular course is been added by which particular student is taking that particular course. Student ID 3, that is Abhishek, is taking the course 7 over here. Okay, so there will be a multiple mappings this way. This will be a many-to-many mapping handled by the third table, that is a joining table over here. So this is a many-to-many relationship in JPA. So here you can see that we have covered a lot of things over here. We covered all the relationships like one-to-one, one-to-many, many-to-one and many-to-many relationships. We did paging and sorting as well, how to get the data in the pagination form and in the sorted form as well. We also implemented the native queries and JPL queries as well. And we also implemented the named parameters. We also went ahead and saw how to do transactional and how to do the modifiable queries as well using the JPA repositories. So there is a lot of things that we have covered, and if you have any questions related to any of the topic that we have covered, then do let me know in the comment section below. I will try to resolve your issues as soon as possible. Now as you have gone through everything over here, you will be able to create all the particular different operations and handle everything using this particular JPA itself. Now there is an advanced thing also available using the default entity manager as well, that you can go through the documentation and you can create the entity manager object, and you can also do the custom method implementation as well. Here you can see that we did everything using the interface, but you want to do the implementation, custom implementation for all those particular methods, that also you can go ahead and do that. But ideally, if you're using JPA, this is my preferred choice as well, because this will reduce a lot of coding efforts, and a standard implementation is given by JPA. So all the particular implementation what has been done, that's a standard format. It's well implemented, and we just have to use those particular methods. So we'll be getting a really good performance as well over here. So security is a very important part of the application that we develop. So whatever the user is using your application, that user has to be authenticated and authorized to use your application. So it's a very key feature of your application. So in this video, we are going to learn about the Spring Security, how we can allow the user to register to your system with an entire complete flow, and how to let your user to log into your system using Spring Security, auth 2 and OpenID. So in this video, what we are going to do today is we are going to create a complete registration flow with login functionality for a user. So we'll start with creating the functionality of registration, where user can register to the system using the REST APIs. We are going to create the REST APIs only today, and the same thing that you can implement in your UI application as well. So we'll create a REST API for a user to register to your system, where we will take the first name, last name, email ID, password, confirm password and all those details, and user will try to register to your system. And when user register to your system, user will get an email to confirm that email, to confirm the account, that the details that a user has entered are correct or not. So that particular thing we are going to mimic it today. Once the user confirms its email address, we will be activating the user. We will also add the functionality if the user has forgot the password. So we'll create an API where user can reset the password as well. At that particular time, what we will do, we will confirm its email, that whatever the email a user is entering, if that email is correct and it's available in our system, then we'll send an email with the reset token to change the password. We'll also create the functionality to change the password where a user will enter its email ID, old password and the new password, and we'll validate the old password and email ID is correct. Then we will be able to change the password as well. And we will also allow the user to log into the system with the registration process the user has completed. So whatever the details user has entered in our system, with those credentials user will be allowed to enter our system using the Auth2 and OpenID. So Auth2 and OpenID are the standards within the industry where everyone is using that. You would have seen everywhere, like login with Gmail, login with Facebook, login with Twitter, GitHub, everywhere, right? So that kind of implementation we are going to do today with our custom authorization server. So these are all the fundamentals of security and we are going to implement today. Now as we talked that we are going to implement a complete registration process with the login functionality with Spring Boot, let's go to the IntelliJ IDEA and let's create a simple Maven project, and in that we will be adding our different modules for registration and authorization server and whatever we are going to implement. So let's fire up the IntelliJ IDEA. Okay, I'll go to the Maven project, click on next. Let me create the folder, documents, Java workspace, Spring security tutorial. I'll open it and this is the project that I'm going to create. Let me add the coordinates, com.daily code, buffer, artifact as Spring security tutorial, version as this, and finish it. So within this we are going to add our project as a module. So let's create the first project. Let me go to the browser and here let me go to the start.spring.io. The group ID I'll give as com.daily code buffer and the artifact I'll give is Spring security client. I hope the spellings are correct. Client. Yeah, I'll give the package name as client, packaging is jar, Java version is 11, and let's add the dependencies. So I'll add the web dependency, I'll add the Lombok dependency, then I'll add the GPA dependency, then MySQL driver with Spring Web, Lombok, Spring Data JPA and MySQL driver. So I think with this we'll be able to create our application. We will add the Spring security module later in this video. So let's generate the project and add as a module in our IntelliJ IDEA. So I'm just generating the project over here. I'll go to documents, Java workspace. Okay, now here you can see that the project is showing up. Now let me add the module over here. Okay, inside modules I'll add the module Spring security client and I need to change the packaging as POM. Here you can see that my project is showing up and this is my details. The Spring version I'm using is 2.6.3. Spring Data JPA is added. Spring Starter Web is added. MySQL connector is added. Lombok dependency is added. Okay, all the things are added. Let's go to the src main resources and let's change the application.properties to application.yaml. So I'll do refactor rename to YML. And I'll change the property that this should run on server port 8080. Now let's add the another dependency about the MySQL connector and the JPA. What I'm doing is I'm just pasting the details over here. It's pretty simple. Okay, you can see that spring.datasource.url I have mentioned over here. Currently I am using the MySQL in my system, so I have given the path of the MySQL, that is JDBC MySQL localhost 3306, and I'll give the schema name as well. But before that we'll create the schema. Okay, after that I've given the username and password of the my database, and the driver class name I've given spring.jpa.showSQL2, so all the queries will be printed, and Hibernate DDL auto is update, so whenever there is a change in our entities it will be reflected in our database. So this is the standard configuration that we have added in our system. So now let's go to the MySQL and create the schema. So I'll just open the MySQL workbench. Let me connect. So I'll create the new schema and I'll say it's a user registration. Okay, apply the changes, close, And here you can see that the user registration schema is created. I'll use the same in our IntelliJ IDEA. Okay, this is my user registration schema. Now within this particular application, we are going to build a complete registration flow first. So for that, let's create the different packages that we are going to need. So we go to the Java, in the client package, we'll create the different packages. Controller, entity, service, repository, and model. I'll create one more. If any configuration that we have to do, we will add that in the config folder. So these are the standard packages that I have created. Now let's start to build our application. So firstly, we'll create the controller, registration controller. Okay, and we'll annotate this with @rest controller annotation. Okay, my controller is ready. Then let me create the entity as well. The entity I'll create as a user entity. And we need to annotate with @entity. Now let's add the different properties as well. So I'll just add private long ID, private string, first name, private string, last name, private string email, private string, password, then private string role. What is the role of a user? Okay, then I'll just add one more, private boolean enabled equals to false. By default, the user would be not enabled, disabled. Okay, so these are the fields that I've added. What I'll do, I'll just annotate with @ID, and I'll just use generated value strategy equals to generation type dot identity, and I'll use the Lombok to add the getter setters and everything @data annotation. Okay, so my user entity is ready. And one more thing I'll add is in the password, I'll just add one validation, that is column length should not be more than 60. Okay, so I'll just do length equals to 60. Okay, so maximum password should be 60 characters. As we are going to use the Bcrypt password encoder, we will be encoding the password in the hash code values using the Bcrypt encoder, and we are going to store that password in our database so no one can see the password. So these are the details. Now let's create the service and repository. So first let me create the repository. Within the repository package, I'll just create a Java class and I'll say user repository, and that will be the interface. I'll annotate with @repository, and user repository will extends JPA repository. This JPA repository is of type user and ID is of type long. Okay, now within the service, let's create the service interface and the implementation of that particular service as well. So let me create the class, and I'll say it's a user service, and it's an interface, and I'll do the implementation for that as well. That is user service implementation. That's a class that will implement user service. Okay, and this will be annotated with service annotation. So my controller is created, my entity is created, repository is created, and my service interface and the service implementation for that interface is also created. So now all the basic classes are created. So now let's go and implement the registration flow. Before that, let's announce the winner of the giveaway of the MX Master 3 mouse. And the winner of the giveaway is whatever the user popped on the screen. So I'll be reaching the user from the comments that they have added in that particular video to get the contact details so I can ship the product to them. So congratulations to the winner and thank you so much everyone for participating in the giveaway. Now if you are feeling that you have missed out on the giveaway, so don't worry, there will be a lot of giveaways in the future, and if this permits, there will be a bigger giveaways as well. So keep supporting and thank you everyone for participating and congratulations to the winner as well. Now let's go to the registration controller and create the REST API. I'll go to the REST controller over here. And here let's create the APIs. Now before adding anything to the registration controller, we need to create a model as well. So let me just first create the model and I'll just say it's a user model. And here I'll add the same properties that I have added in the user entity. I just need these details. I need password as well. And there should be matching password as well, right? When you are creating the form, you will be adding the matching password as well. Annotate with data, no args constructor and all args constructor. Okay, so my model is ready. So let me go to the registration controller and let's create a method. Public string register user, and this will be @post mapping to /register user. I'll just keep it register, that would be better. And I'll be taking the request mapping as well. So I'll just take request body, and this request body is nothing but your user model. Now at this point we need the user service object as well, because we are going to call the user service, and from that particular user service we are going to call the repository. So let me just create the object for that. Private user service, and I'll just auto wire it. And I need the user object. The user is com.dailycodebuffer.client.entity. This one. User equals to user service dot, I'll just do register user, and I'll pass the user model. Okay, I'll create the method, create method register user in user service. Okay, I'll go to the implementation and I'll implement the method, and in this particular service I'll need the user repository as well. So let me just create the object for that as well. Okay, and I'll just use @autowired. Now in this particular, let me create the user object. User equals to new user, and all the fields from the user model I'll set to the user. So user dot set email, I'll do user model dot set email, user model dot get email, user dot set first name equal to user model dot get first name, user dot set last name, user model dot get last name, user dot set role, and I'll just do user role. Okay, for now, but later we can create this particular thing as a dynamic as well, but currently let's make it simple to understand, because we need to understand the security part more. And user dot set password as user model dot get password. Now one thing to note over here is whatever the user dot set password that we are doing over here, that is the plain simple password that we are getting from the user. But when we set to our database, we need to convert that to the encrypted password. So we need to use the password encoder to encrypt the password before saving to the database. So let's do that first. Now for this particular password, we need to create a config. So let me just create a new Java class, and I'll just say web security config. And for now, I'll just annotate with @configuration, and I need the password encoder. So what I'll do, I'll just say password encoder. So to use that particular password encoder, we can see that we are not getting the class, so we need to add the Spring Security to our project. So let's go ahead and add the Spring Security. So let's go to the pom.xml file. Let me go to the browser. Within this same project, let me add the security. Okay, and if I go to the explore, I can take this Spring Boot starter security. Okay, so let me add the dependency, and for the testing purpose you can add this as well. So let me add that dependency as well. So if you want to add the test cases for this, you can add these. Cool, right? So now let's get back to the web security config, and here rather than using the configuration, I can directly use enable web security. Okay, let me remove the imports, and here I can use now password encoder. So I'm not getting the class over here, so let me restart the Maven so I can get it. So what I'll do, I'll just revalidate the cache. So sometimes this kind of issue will happen, so you need to invalidate the cache and restart the IntelliJ IDEA. So now you can see that I'm getting, right? So I'll just use it and use password encoder, and I'll just do return new bcrypt password encoder, and I'll just use the strength as 11, and I'll define this as a bean so I can auto wire it. So if I go to my user service IMPL, here I can use it. I can use private password encoder, and I can auto wire it. Okay, and now when we are saving the password over here, before that we'll just use password encoder dot encode. So this password will be encoded over here, and then once everything is set, user repository dot save user, and we will return back the user. Simple, right? So user service implementation is done. Now let's go back to the controller, and here what I'll do, I'll just return success. Okay, so you can see that the one part is done, that whenever a user will try to register to the system, the data will be saved to the database and the user will be disabled in the starting. Now we need to send the email to the user, so that with a particular link, so that user can click on that particular link and the user can be activated. So that's the standard process, right? So for that, what we have to do is we have to create the event for it, because that's the other task that you are doing. The particular process that you are doing over here, that should not take the extra time for that. Okay, so what we'll do, we will just separate out the process. We'll create one event, and that particular event will handle to create the particular email and send the email to the user. So that's what we are going to do. But if you want to test out till this particular flow, you will be able to test it out, and the user will be saved to the database with the disabled as a status. So here what we'll do, to send an email and to separate out the process from this flow, we will create the event. So let me just create the object of the event. We will be using the application event. So we'll just define private application event publisher, and I'll auto wire it. Now once we get the user is saved to the database, we can create the event. So at this particular point, I can say publisher dot publish event. Okay, and now here you can see that this particular publish event is taking the application event as the input parameter. So we need to create the event that we want to publish. So let's create the event. So for that, let me just create the event package over here. Okay, within this event package, I'll create the Java class, and I'll say this is the registration complete event, which will extends application event. We need to create a matching constructor for the super. Okay, so let me just create it, and here we'll be taking the user object, user, and I'll be also taking one string as the application URL. Cool, right? So here you can see that the event is created. Now I want to have this two particular field as well. So let me just do one thing. I'll just say private user and I'll just say private string. I'll copy this application URL as well. Now this particular application URL is nothing but a URL that we have to create for a user when we send the email to click on it. Okay, so that's the thing. And from here, this dot user equals to user, and this dot application URL equals to application URL. Okay, now my event is created. Now I can publish this event. So if I go back to the registration controller, I can create the new registration complete event. Okay, and here I need to pass user object first, and then I need to pass the URL. So let me just keep a string for now, but later we will create we will build the URL. Okay, so this particular part is complete. Now we just publish the event. We need to listen that particular event and we have to do something on it. Okay, so let's create the listener for that particular event that we have created, that is the registration complete event. So I'll go to this particular entity package, and within this I'll just create one more package. This will be list in your listener, and within this listener let me just create the Java class, that is registration complete event listener. Okay, and this particular class will implements application listener. Okay, and this particular listener is of which type? That is the registration complete event, and we need to implement the method. So let's do that. Okay, so this is the implementation part. Now at this part, what we'll do, we'll create the verification token for the user. Okay, so whatever the token will create and will attach to the link, so that when a user clicks, the user will redirect back to the application. Okay, with link. So we'll create a link over here, and once the link is created, we can send mail to user. That's the two things that we are going to do over here. So let's get the user now. User equals to, we'll get the user from the event. So we'll do event dot get user. So when we go to the registration complete event, here we will add the getters and setters. Okay, because I just need the getters and setters. So let me go back to the registration over here, and I'll just use the get user, and I also need string token equals to, and the token I'll just create as a uuid dot random uuid dot toString. Now whatever this particular token is, right, that particular token we can save for a particular user, so that whenever a link is hit by the user, that particular token and the token that we have in the database, we can match that particular token, and then only we will be verifying the user. Okay, so we need to save this token as well. So for that we will create the entity again for it. So let's go ahead and create the entity for it, and for that particular entity we have to attach the user as well. Okay, so I've done the mistake over here, that listener I have added in the event. So let me just drag and drop to the event. Okay, now in the entity let me create one more entity, and I'll say this is a verification token. This will be entity, and this will be data as well. Add the ID attribute. Okay, and here I'll define one more thing, that is private string, that is token, and private date expiration time. Okay, when that particular token will be expired. So we will generally give about 10 to 15 minutes of time for a token to expire, and we'll also give for which particular user. So we'll do one-to-one mapping for a user over here. So here we'll just define one-to-one mapping, and we'll define fetch equals to fetch type.eager, and we will do the join column over here. The name of the join column will be name equals to user ID, nullable false, and the name of the foreign key. Foreign key equals to @foreign key, and the name of the foreign key. I'll just do fk underscore user verify token. Okay, let me just reformat the file. Cool, right? We have added the verification token as the entity as well, which will have ID, token and expiration time. Now from here we need to create the couple of constructors so we can pass the user and token to this particular entity. So let me just create that. Let's create a constructor verification token where we can just pass the user as well and the token. This dot token equals to token and this dot user equals to user. And one more field that we have is the expiration time. So how that particular expiration time would be calculated. So for that, let's create the method. This dot expiration time equals to calculate expiration date. And here we need to pass some static values. So suppose let's create one static value over here. Private static final int expiration time. Okay, so I am going with the 10 minutes of time. Okay, expiration time as 10 minutes. So this is something that I'll pass over here, that this is the expiration time. And let me create the method. So I'll use calendar equals to calendar.getInstance, calendar.setTime in millis, and we'll pass the new date dot-getTime. Now with this we will add some time, calendar.add, and we'll add calendar.minute, and we'll just add expiration time, and we'll just use return new date calendar.getTime. Okay, simple thing. You can see that whatever the expiration time that I'm passing over here, I'm adding to the current time and I'm passing the value over here. So it will be around 10 minutes from the system time. So that will be set over here. And I'll create one more constructor over here, public verification token, where it will just take the token. So if I just want to work with the token, okay, I'll just call the super, and this dot token equals to token, and this dot expiration time equals to calculate expiration time, and I'll just pass the expiry time. Simple, right? And here let me just add the noargs constructor. Okay, so this verification token is created. Now let's get back to the event listener. Now at this particular point you can see that I have got the user and I have got the token as well. Now at this point I can save the token and user to the database. So here as well I will need the user service. So let me create the object for it. Private user service, and I'll just auto wire it, and I'll just say user service dot, I'll just create one method that is save verification token for user, where I'll just pass the token and user. Okay, and I'll create the method. Let's go to the implementation over here, and here I can implement the method that is the save verification token for user. Okay, now here what we'll do, we'll just create the object of verification token equals to new verification token, where we'll pass the user and token. And for this particular verification token as well, we need to have a repository, right? Because we have not created the repository for this. So let's go ahead and create the repository. This repository package, let's create the new interface, and we'll just say verification token repository. Okay, this is the interface, and this will extends GPA repository this JP repository is of type verification token and of long, and we'll annotate with repository. Cool, right? Now the repository is created. Let's go to the event listener. This is working fine. Now let's go to the user service IMPL. The verification token is created, and I need the object of verification token repository as well. So I'll just do private verification token repository, and I'll auto wire it. Simple, right? And this I can use over here, that verification token repository dot save verification token. Super simple, right? Now my user and token both are saved to the database. Now at this particular point I need to send email to the user. Now what we are doing over here is, to save the time, we are just mimicking that we are sending the email. If you want to actually send the email, I have created a dedicated video on Spring Boot where I am showing you how to send the email from any of the email client. That is in that particular video we are using the Gmail to send the emails, so that you can implement over here. But here we are just mimicking that we are sending the email, and we are printing that email in the console, so we can get the URL and we can use that particular URL to verify. So now let's get back to the registration event listener, and here you can see that create the verification token for the user with link. This particular part is created. We need to create the link now, and we need to send the email. That particular part is remaining. So let's implement that. So here I'm creating the URL, string URL equals to event dot get application URL. So this particular application URL, we have not yet implemented the particular method to create the application URL, but we will implement, and we are hoping, or we are assuming, that we will be getting the application URL to the context path. Okay, and then we can add the path from there. So from here I'll just append the path, and here I'll just pass it plus verify registration. So this is some path that we are going to implement: registration, verify registration, and I'll be passing the token equals to plus token. Simple. You can see that this URL will have the application URL, that will be your context URL, plus, so this is some API that I'll be creating, that is the verify registration, and as the parameter I'm passing the entire token. Okay, let me use the SLF4j over here to print the logger, and I'll just print log.info, and I'll print over here is click the link to verify your account. Okay, and here I'll pass the URL. I think this is pretty simple, that we are passing the verify registration, that one endpoint. This endpoint we are still going to implement, and we are passing the token over here, and we are just mimicking that this is the email, but ideally this is where you will send the email. You can create the send verification email method over here. You can pass the details and you can implement it over here. Okay, so this is the mocking that we are doing over here. Now the application URL. So this application URL we are passing from the registration controller, right, at this particular point. So let's mimic this URL. Let's create the URL. So for creating the URL and to get the context of the URL, you will need the HTTP request. So let me just inject that. I'll just use final HTTP servlet request, and here I'll create one method, application URL, and here I'll pass the request, and let me create the method, and from here we can create the URL. Return HTTP plus request dot get server name plus colon plus request dot get server port plus request dot get context path. Okay, so this is a simple method where it's returning the path. Now this particular flow, you can see that it will come over here when we are going to register. It will pass the user model where it will have the first name, last name, email ID, password over here. We are going to pass from the response body, means from the as a part of a JSON, and it will save the user over here. We'll get the user back, and we will create one event where that particular event will send the token to the user in form of an email, and that particular email can be used to verify the user. Okay, that's standard flow that we are going over here. So everything is implemented, I guess. Let's re-verify. Okay, cool. So let's start the server. Okay, your server is started. Now one thing to note over here is when we go to the browser, okay, and when we go to the localhost 8080, and here you can see that we are by default getting a sign-in page, and this particular sign-in page is from the Spring security that we have added the dependency. Okay, and currently there is no user or there is no extra configuration that we have done that Spring security will understand. So what Spring security is doing, that it is giving the password as well. You can see that this is the password that we can use, and the default user is the user to log into the system. That's what we can do over here, but we do not want to use that. We need our custom implementation. So that is something that we are going to implement. But for this particular API, right, currently whatever the API that we are using, that particular API is also protected. So that API we need to bypass. Like when we want to register, it is not necessary to log into the system, right? Because we want to create the user. So there will be some whitelisted APIs or whitelisted URLs that we want to bypass, and for rest of them we need to enable it. So that is something that we have to implement. Okay, that is some configuration that we have to do. Currently we won't be able to log in directly or use any of the API directly. So let me add the configuration for that. So we are going to implement a security filter chain over here. Security filter chain, and this will be the bean that will be defining, and this will be taking HTTP security as the input parameter. We'll be injecting HTTP security, and now we can do something on the HTTP. So what we'll do with this HTTP, we will disable the CORS and .csrf disabled. Okay, so we are just disabling the thing over here, and it requires the exceptions. I'll just add in the method signature. So I am telling that there will be some APIs that you need to handle, and this all the APIs I need to permit. Okay, what will be the APIs? I'll define over here. So let me just define private static final whitelist URLs, and this is string of array. And which are the URLs I can define? Okay, this is hello. I can define /hello. I can define one more, that is the registration controller /register. Okay, and I'll define over here that whitelist URLs. So this should be permitted all. So any URLs which have this pattern will be whitelisted. Okay, will be permitted. And I'll just do return http.build. So this is a simple security that I have defined over here, that I'm just disabling the CORS and CSRF, so I can do post requests and everything for now. And I'm allowing all this particular URLs, whatever I have defined over here. So in the future, whatever the other URLs that we are going to build, that will be protected behind the securities that will be defining later. So let's start the server again. And here you can see that the application started. And if I go back, and here you can see that I am able to directly call the hello API. Right, so one thing is working fine. Now the same way register one we can use using the Postman. So from the Postman, let's try to register one user. And before that, if you go to our database, let me refresh all, and within this user registration you can see that the tables are created, that is the user and the verification token. Okay, currently we see there should not be any data. Okay, there is no data in either of those table. Now let's go back to the IntelliJ IDEA and this is something register that we have to call, right? So let me open Postman. Okay, let me create the new request over here. This will be the post request and http localhost :8080/register is the URL. Let me reconfirm. We'll go to the registration controller. Register is the URL and we are going to use the input parameter over here, that is the first name, last name and everything. So let's define in the body raw binary JSON, and let's define I'll define first name, last name, password and email. Okay, first name is Shabir, last name is Daudi, password I'll give 12345667 and shabir@gmail.com. Simple, right? So these are the details that I'm passing over here, and if I click on send, you can see that I am getting the response success over here. Okay, and if I go to the database, hit on user, you can see that I'm getting the email, first name, last name and password. You can see that it's encrypted using the Bcrypt. My role is user and enabled is 0, so it's false now. And if I go to the token, you can see that the token is not created, so there is some issue. So let's check. So if you go to the, so you can see that the user entry was inserted over here. Okay, but the verification code was not inserted. The issue I can see over here is this is not a component yet, right? So Spring doesn't know about this yet. So let me just add this as a component. So Spring knows about this and this will be executed. So let's restart the server. Okay, server is restarted. Now let's go to the MySQL and let me just delete this. Okay, so no records now. Okay, and let me go back to the Postman, and from here let's hit send. Okay, success. If I go back to the MySQL, user is there, verification code is also there, so my event is also working fine. You can see that the token is created, user ID 2 and all the details. Now if I go to the IntelliJ IDEA, here you can see that the event is created and the link is also there, like click the link to verify your account, and this is the link. And we forgot something over here, that is the /, right? So we will add that / over here, and the token is this particular token. So you can see that we are able to create the link, and this is something that you will be sending the user in the email, but we are just mimicking over here. Now we need to handle this verify registration. Like whenever a user is clicking on this particular URL, when there is a verify registration, we need to take this token, and that particular token needs to match with the token that we have within that time frame, right? So if a particular user is doing after 10 minutes, then we need to define that token is expired. And if it's not, if token is valid and within the time frame interval, we should be validated and we should be activating the user. So that's what we are going to do. So let's first correct this URL. After 8080 we will add the / and then we will implement this verify registration API. So here we'll define this. Okay, and now what we'll do, we'll go to the registration controller. There is one post mapping, right? So we'll create one more. Okay, here let's define public string verify registration, and this is the get mapping, where we will define the / verify registration, and there will be one token. So I'll just define, there will be a request param token, and the request param name is also token, and I'm defining over here string result equals to user service dot verify instead of verify we'll just say validate verification token, and here we'll pass the token. Okay, and here I'm defining if result dot equals ignore case valid, I'll be passing valid or invalid from the method. So if it's valid, return user verified successfully, else return bad user. Okay, simple thing. Now let's implement this method. Let's create the method in user service and let's implement the method. This is in the user service implementation class. Now here we need verification token. Verification token equals to verification token repository dot find by token, and I'll just pass the token. Okay, and this particular method we need to implement. So let me just create the method find by token. It will take the token as the input parameter and it will pass the verification token. Here we got the token. Now if verification token equals to null, then just return invalid token. Now after this I need to get the user from the verification token and I need to check the expiration time as well. So let me just do that. I'll just do user equals to verification token dot get user. I'll create the calendar object equals to calendar dot get instance. Now I need to check something over here. If verification token dot get expiration time dot get time minus cal dot get time dot get time is less than equal to 0. So you can see that the time saved in the database minus current time is less than 0. That means the token is expired. So we need to make that happen, that the token is expired. So let me just format the code. Here we need to make sure that the token is deleted from the repository. So I'll define verify token repository dot delete verification token. Okay, and return expired. So now at this particular point we have verified that the token is also valid and it is not expired as well. So we need to do user dot set enabled as true. We are enabling the user and we are saving user repository dot save user back and we are returning valid. So yeah, you can see that it's very simple, right? We are just checking that whatever the token that we are getting, that token exists in the database or not. If not, it's an invalid token. If so, we are getting the user, and with that particular user we are getting the calendar instance and we are checking the expiration time. If that particular expiration time exceeds, then we are deleting the token and we are just telling that it is expired. Otherwise we are enabling the user and we are saving back to the repository. So we'll go back to the registration controller and you can see that the complete flow is done, right? Now let's restart the application. Okay, application is restarted. Now let's go to the database. Okay, let's delete everything so we can see better. Let's delete apply. User deleted. Okay, so there are no users and no tokens available. Now let's go to the Postman and let's create this user. So we'll click on send and the user is created. If you go to the database, the user is there and the token is also there. Okay, so what we are going to do over here is we are going to get this URL. Okay, you can see that the URL is there. So copy URL, we'll go to the browser to verify. Let's go to the browser. Let's verify. And you can see that we are getting user verified successfully. Okay, spelling mistake is there. I'll correct it out. Okay, so if you see over here, if you go to the database, earlier you can see that the enabled flag was 0, so it was disabled. Now if I again requery it, you can see that it is verified successfully. So now user is verified. So this is the complete registration flow. You can see that. We can also check some of the failure scenarios where we can just change the token, and if we hit, you can see that we are getting the bad users. So the token is bad, right? So if we wait for 10 minutes, okay, after 10 minutes if the token is expired, then what it will do is it will delete the token itself. Okay, so this way you can implement the complete registration flow with the token implementation, where you are sending the token and that particular token is been verified in the database. Now once this particular complete flow is done, there might be a scenario where you didn't get the email, or there might be some issue in the server where you didn't receive the email. So you might have seen this everywhere, like there will be a recent functionality, right? Recent token or recent OTP, whatever. So for this particular registration process also, we can implement that particular functionality where when we click on that particular button, it will regenerate the verification token and it will send in our email. So that particular token also we can use to verify. So let's go ahead and create the functionality where we can ask for the regeneration of the verification token, and that particular token we will be using. So let's do that. Let's go to the IntelliJ IDEA and let's implement that functionality. So currently you can see that everything we are doing from the REST APIs. This REST APIs you will be using in your UI application. So let's create the method that is public string resend verification token. Okay, I'll annotate with get mapping and I'll just say resend verify token. Okay, you can give any name, and here what I'll be taking is I'll be taking the old token. Okay, whenever there is a request from the UI to the backend for this re-verification token, send that old token as well. So from that particular old token we can verify. So I'll just take the request param, and this is the token string old token, and I also need the HTTP request to generate the URL again. So HTTP servlet request and request. So here what I'm doing, I'm just creating the object of verification token. Verification token equals to user service dot generate new verification token. Okay, and I'm passing the old token over here, so I'll get the new verification token. So let me just create this method. Okay, I'll go to the implementation part and I'll implement the method. Now with this particular verification token, old token, what I'll do, I'll create the object of verification token. Verification token equals to verification token repository dot find by token, and I'll be passing the old token over here. Okay, so if I get the token, what I'll do, I will set the new token, verification token dot set token, where I'll pass the UUID dot random UUID dot toString. So I will just set the new token, and with the help of verification repository I can save the token back to the database and can return the token. Okay, so at this point I'll get the token over here in the controller. So let's go to the controller. Here I'll get the token. Here I'm taking the user out of that. User equals to verification token dot get user. Now at this point again we need to send the email, right? Like this is your new verification token, verify this for your particular user. So we can create one method where we will be sending the email. So we can just say resend verification token mail. Simple method I'm creating where I'm passing the user object and I'm passing the application URL with the request, and I can say to the user that verification link sent. Simple, right? So now let's create the method. So this is the method that I'm going to create. So let me add the code over here. Okay, so for this I'll go to the application event listener and I'll get the URL and this logger message. Go over here, let me paste it. URL equals to, instead of this I'll just directly use the application URL. Okay, verify registration, blah blah. Okay, I need the token as well over here, right? So let me just pass the token as well. So what I'll do, I'll pass the token as well, verification token, and I'll update the method, okay, where it's taking the verification token. Here verification token dot get token. Okay, so here you can see that the URL is created, and click on the link to verify your account. And for the loggers, let's add the SLF4J. So resend verification token email, this is implemented. Ideally you will be sending the email, but to save the time we are just printing out in the loggers. So this is a method where you will be sending the verification token again. So this is also a new API, so let me just handle this in the Spring Security. So if I go to the web security config, and here we can add. Okay, now I'm adding currently now, but it will be helpful later. Currently I have permitted everything, so currently there won't be any error, but the list we are maintaining will help us later. Okay, so let me just add for the verify registration as well. So now let's build the application again. Okay, application is started, and let's go to the Postman and let's change something. Okay, instead of Shabir I'll just say Nikhil Gupta, password 1234, and I'll just say Nikhil at gmail.com, and we'll click on submit to create a new user. Okay, new user is created, success. Okay, users are there. You can see that the verification token is also created, and you can see the token is starting from 2855C53. Okay, so it's from the 2855. Now if you go to the IntelliJ IDEA, you can see that you are getting the link as well where you can verify. Okay, 2855. But now suppose I didn't receive it. Okay, just assume we didn't receive it, so we need to call that again. So what I'll do, I will call the API again. Okay, so let me just go to the registration controller, and you can see that it's the resend verify token. So instead of verify registration, the same URL, let me just copy it. Okay, copy URL, go to the Postman, new request, and instead of resend verify token, this is something we need to change, instead of verify registration. Okay, so what it will do is it will try to check this particular token. If this particular token exists in the database, okay, that at that time what it will do, it will replace with a new token and we will get a new token. Okay, so let's hit this URL. You can see that we are getting the verification link sent, and if we check the database, the earlier token was 2855. If I hit the query again, you can see that the new token is generated, and the token is 41723, something like that, and the same link would be generated here as well. You can see that the link is generated, verify registration token is the new one. And when we copy this URL, go to the Postman, new, okay, and we can click on send, and you can see that user verified successfully. Okay, so my complete flow is working, where we are registering the user, we are verifying the token, and if we didn't get the token, we can ask to resend the token as well. That is also completely working fine. Cool, right? Now what we are going to do is we are going to implement the functionality of the reset password, because if we forget the password at the time of login, we need to reset the password, right? That also will be implemented using this particular token flow with the email, and later we will be implementing the change password as well. Now we'll create one method where user can click on reset password, and user will get an email with a link, just like the way we have created all this, right? It will be a link where when we click on that particular link, it will be to add the new password, and that particular new password will be saved. Okay, just imagine that you are clicking on the link and you are getting the page, but here we are going with the REST API. So we'll be creating a REST API where we will be getting the new passwords and token and email ID, and based on that we will be saving or we will be updating the password over here. So let's create a method that it will create a link for a user to reset the password. Okay, so let's do that. So we'll create a method over here, public string reset password @post mapping, and I'll say reset password. Here we'll be taking the request body and we'll be taking one object. So let's create one object. Let's go to the model and we'll create a class password model. Let me annotate with data private string email. Okay, currently let me just add this. Later when we need any other details, we will add the details in this password model. Let's go back to the controller. In the request body, we will be taking password model over here, and let's implement the functionality here. Okay, so here what will be, user will be passing the email ID with which they have created the account, and we will validate if that particular email ID is present in our system. Then with that particular email ID, we will be creating a new password token and we will send that token to the user over email. With that token, we will again validate and we will ask them to reset the password. Okay, so let's do that. We'll do user equals to user service dot find user by email, and we'll pass password model dot get email. Okay, let's create the method. Let's implement the method as well, and here we will return user repository dot find by email, and we'll pass the email. Okay, and this particular method we have to add in the repository. So let's create the method. It will return the user based on the email that we are providing. Okay, now here I'll be getting the user. Okay, and here we'll check if user not equals to null. Now we got that user particular, right? If user is not null, then I can create a new token and save the token for the password reset. So let me just create the token. String token equals to uuid dot random uuid dot toString, and we'll call the user service dot create password reset token for user, where we'll pass the user and token. Simple, right? And let's create the method and we'll implement this method as well. Now for the password reset token as well, we need to create the entity. The similar thing we will do as we had done for the verification token. So let me just create the entity. I'll go to the entity package and create the new password token. I'll just name password reset token. Okay, I'll go to the verification token. I'll copy everything from here, and the password reset token I will add all the details, and I'll change the constructors, and I'll annotate it with entity data and noax constructor. Okay, so let's do that as well. Entity @data and @noax constructor, and we'll change the foreign key as fk user password token. Okay, super simple. We just created the similar thing for the password reset token as we had done for the verification token. Now let's go back to the user service IMPL, and in this method let's create the object of password reset token. Now for this password reset token we need to have the repository. So let's create the repository. For that we'll go to the repository section. Let's create the new Java class. It should be interface password reset token repository, and this extends JPA repository, and this JPA repository is of type password reset token and ID is of type long, and we need to annotate with @repository. Cool, right? Now let's go back to the user service IMPL. We created the password reset token, and now we need to add the password reset repository over here. Private password reset token repository, and we'll auto wire it. And this repository will use to save the data. Password reset token repository dot save password reset token. Simple, right? Now let's go back to the registration controller. At this particular point, your password token is set. Now you need a URL. Let's create the URL so that we can hit that URL to reset the token. So I'll just define the URL. Okay, string URL, and for the URL we will create one method, password reset token mail, similar to what we did for the recent verification token email, where we'll pass the user object, and for the application URL we will pass the application URL where we need the request. So let's inject the HTTP request as well. Okay, we'll pass the request and we'll pass the token as well. Let's create the method. Let me refactor this method. The name password reset token mail. Okay, now here what I need, the similar thing, I'll just copy this and I'll paste over here. I'll just use the token over here, and here instead of verify registration I'll just say save password. Okay, this is the link that I am creating, and click the link below to reset your password. Cool, right? And this URL we will return from here. Now when you click on this URL, you will be redirected to enter your new password, right? New password, and the confirm your new password. So at that particular time we will be needing more details to save the password. So let's create a method to save that particular password. So here when you click on reset, here you will get a link. When you click on the link, you will pass more details to save the password. Now this particular save password we will create public string save password. Okay, this is post mapping, and I will give the same thing, save password. Okay, here you can see that it is taking the token as the request parameter. So let's add that @request param token, which is string token, and it will also take the extra data as a JSON format, right? Like your new password and the email ID, whatever it is. So for that I will just use this particular password model as a request body. So let me just add it below over here, @request body password model. Super simple, right? Now here we need to verify the token and we need to save the details. So first let's verify the token. String result equals to user service dot validate password reset token, and we'll pass the token, and let's create this method. We'll go to the implementation and we'll implement this method. And here it would be similar to what we have done earlier to verify this token, right? So I'll just copy this information from here. I'll paste it, and I need to change some details. Instead of verification token, it would be password reset token and here I'll refactor the name password reset token, and this find by token we need to create. So let's create this method. If we go to the user, sorry, this should be password reset token repository, and this we need to change. We need to implement this. So let me just add the method. Okay, in the password reset token repository. Okay, now we are checking if password reset token equal to null, invalid. We are getting the user from the password reset token. We are getting the calendar instance password reset token dot expiry time and all. And here we need to use the password reset token repository, delete password, expired, and okay, and I don't need these details, so let me just remove that. Simple thing, we are just validating the password reset token. If token is not available in the database, it's an invalid token. If token is expired, then it will be expired, otherwise it's an invalid token. Okay, let's go back to the registration controller, and here we will get the valid now. And here we will check if results dot equals ignore case valid, and I'll negate this sentence. If it's not valid, then I'll just return invalid token, okay, or expired token, whatever. Now at this particular point my token is valid. Okay, so I need to update the password. So for that I'll go to the password model first, and let's add few fields: private string, old password, and private string new password. Okay, these three fields. Now let me implement optional user. Okay, user equals to user service dot get user by password reset token. Whatever the token is, based on that I need the user back, so I can change the password. So here I'll just pass the token, and let's implement this method. Let's go to the implementation and implement this method, and here we will pass return optional dot nullable. Okay, optional dot off nullable. We will do password reset token repository dot find by token. We will pass the token dot get user. Simple, right? We are getting the user from this token. Now let's go back to the controller. Now here we need to check if user dot is present, do something, else do something. So if user is present, we need to change the password, else invalid token. And here I'll just say password change, not password change, password reset successful. Okay, and here we need to change the password, set the password, so we need to call that method. So here what I'll do, I'll just say user service dot change password, and here I'll just pass user dot get and password. So I'll just do password model dot get new password. Let's implement this method. We'll implement the method, and here we'll just do user dot set password, password encoder dot encode new password, and user repository dot save user. Password is saved now. So now here you can see that we created two APIs to reset the password and then to save the password. So now let's restart our application and let's test this functionality. Return statement is missing. Let's handle that. Password reset token email. Return URL. Let's run it again. And here you can see that your application is started, and you can see that your new table is also created for the password reset token. If you go to the MySQL, let's refresh everything, and here you can see that your password reset token is also created. Okay, cool. Now what I'll do, I will try to reset the password for this particular user, that is Nikhil. Okay, currently you can see that the password is something like this, which is GEMVN, something like this. Okay, so we'll change the password. So what is the URL that we have to create? Let's go back, and to reset the password, we need to call the reset password, and in the body we need to pass the email ID. Okay, so we will do that. Let's go to the Postman. Let's close this get request, and let's copy this post request. Reset password, will copy this and paste over here. Go to the body, raw JSON, and we'll copy the email from the database itself. So let's copy the email. Okay, sorry. Okay, so for this particular user, when we hit on send, I should get a URL, and with that particular URL, if I pass more data, that is my password, then I should be able to change the password. Currently there is no reset password token over here. Okay, so if I click on send, you can see that I got the URL, that is save password, and this is the token. And if I check the data, you can see that I have a token available, okay, for my user. Now I need to use this in my new URL. This is also a post request, and in the body save password, I'm getting the token as well, and in the body I must get the token that I'm passing, okay, and I must get the new password as well. So let's do that. So the token I'm providing over here from the parameter itself. For the body, let me go to binary raw text to JSON, and here let me pass the new password. The new password I'm passing is 123. Okay, simple thing. I'm passing the token, new password, and I should be able to save. Let me just check that the new password attribute is correct. New password, I'll just copy from here. Okay, now hit on send. You can see that password reset successfully. Okay, and if I go to the database, current password, you can see that it's starting from GEMVN. Okay, this is some password, encrypted password, and let's requery it, and you can see that the password is changed successfully. So your token also was verified and the new password was set successfully. So this way you can do the reset password verification flow in your application. Now let's do the change password flow. So let me go back to the IntelliJ IDEA, go back to the registration controller, and the same way you did for the save password, you will do for the change password, where in the change password we will get more information. What is the email ID? Because earlier we verified the user based on the token that we created. Now we need to verify the user based on the email ID, the logged in user itself, and then we need to get the old password. If we are able to match the old password with a particular user, then only we will update with the new password. That's the logic, right? So let's create one more API, public string change password. Okay, and here I'll do the post mapping and I'll just say change password. And in the input parameter, I'll take the request body itself. The request body is again password model, and we need to find the user by email. So I'll just do user equals to user service dot find user by email, and I'll just pass password model dot get email. Okay, we had already created this find user by email method, so we are using the same. Now we got the user. Now if user is there, then we need to check the old password. So whatever the old password is entered, that particular password should match with the password in the database. So let's check that. If user service dot check if valid old password, and here I'll just pass the user object and password model dot get old password, then do some if condition, if operation. Okay, so if the password is valid, then we can change to the new password, and I'll completely negate this. If so, return invalid old password. If this is all good, then I'll just say save new password functionality will implement, and after that return password change successfully. Okay, now let's implement this check if valid old password. So let me just create the method. Let me implement this method in the user service IMPL, and here we'll just do return password encoder dot matches, and here this particular matches will take the old password, that is the password that we are passing, that is the raw password, and the other thing is user dot get password, the encoded password. It will try to match this, the old password, the password which we are passing, and the password which is already stored in the database. If it matches, then all good, otherwise we need to raise the exception. So let's go back to the registration controller. It will come at this particular point. If password is all good, then fine, otherwise throw invalid old password. Now we will implement this save functionality, and here we will just say user service dot change password, will pass the user and will pass the password model dot get new password to save the password. That's it, right? We are just doing a simple thing over here. Whatever the password model, whatever the email ID that we are getting the user from that email ID. We are checking if the old password is correct or not, and after that we are updating to the new password. So let's restart the application and test this. Now let's go to the Postman. Let's create a new API request. Let me just copy this. It's a post request. Instead of reset password, it's a change password. And let me add the body data as well. We'll pass the email. Old password, and we'll pass the new password as well. The email ID I'll pass as is of Nikhil. The old password we set was I think 123, but let me pass 567, and the password I want to set is 789. Okay, so at this particular point I should get the error, right? Because the old password is not correct that I am sending back. So if I hit on send, there is some error. Okay, so let's see what is the error. I'm getting the null pointer exception. Obviously, right? Because this particular user is not available. We need to handle all these particular exceptions. Okay, currently we have not handled all the exceptions, but when we are implementing perfectly, we should be handling all the exceptions. Currently I'm just showing you the way. So let me just copy the email ID correctly. Okay, and if I hit on send, currently you can see that invalid old password I am getting. Now if I give the correct password, that is 123, I should be able to update the password. You can see that password changed successfully. Now the password is 789. So currently you can see that we have successfully implemented the change password functionality as well. Now there are a lot more functionalities that you can implement within the entire registration flow, change password flow and reset password and everything. These are all the foundations that I have shown over here, but there are more advanced things that you can do, like handling the IP address and locations and everything. If you want to check out the article from the YouGen, I'll just mention the link in the description below. I have taken the lot of reference from that. So if you see this, right, the complete registration flow with the help of Spring Security, I have taken a lot of inspiration from here. So you can check out this entire tutorial. It's very in-depth than what I have implemented in this particular video. So you can check out this complete flow and you can implement in your project according to your requirement. I highly recommend this particular article. It's implemented very well. So you can check out this article. I'll link this in the description below. Now from here we can understand the complete registration flow, registration with the email, with the token, with the reset token, verify token, change password, reset password, and all the functionalities we have implemented. Now we need to implement the login functionality. So whatever the users that we have created, right, in our database, we will create a login functionality to validate a particular user and to enter into our system. So now let's implement the login functionality. It's very important. Okay, so before we implement the login functionality, we need to understand about the auth 2.0. So you might have seen this auth 2 implemented at many places. So everywhere you go, you will be seeing this particular buttons to log in with those particular authentication providers. There will be Okta, Auth0 and many things. Okay, so these are all the authentication providers based on the auth 2.0 standards. Now before we implement anything, we need to understand about the auth 2.0. So auth 2.0, which means open authorization, is a standard designed to allow websites or application to access resources, okay, hosted anywhere on behalf of the user. So it's like very simple. If I give you the analogy, I have my mobile phone, okay, and if you want to use my mobile phone, you have to take permission from me to use that particular phone. That's a simple thing. So that's the analogy that we are going to understand from there. So I have my phone, that means I have my resources, I have my APIs. If you want to access it, you need to take the permission from me to use those APIs or to use my mobile phone. Okay, so that's the standard that has been auth 2.0. So auth 2.0 is just the authorization protocol and not the authentication. So it only provides the authorization, like you are allowing someone to use your resources. I am just allowing you to use my phone. Okay, simple things. It's just the authorization that you can access this. But what about the authentication? That authentication comes later when you connect OpenID with it. Okay, so auth 2.0 and OpenID connects together and you will get the complete authentication and authorization working together. Now the other important part of the auth 2.0 is it is designed primarily as a means of granting access to a set of resources. Suppose you have a set of resources, like if you take the example of a Twitter has its own API. If you want to access those APIs, you need to request for it, right? You will be requesting Twitter to use it, okay, and the Twitter will give you some extra details about authorization, client ID and all those tokens and everything to use those APIs. So it's just like that. And auth 2.0 uses access tokens. So we will go in detail about the access tokens and how everything works, but this is a basic idea about it. Now in auth 2.0, these are the basic jargons that you need to understand, because everywhere this will be the thing that we will be talking about, that is the resource owner, client, authorization server and resource server. Entire auth 2.0 depends on this and you will be implementing this only. Let's understand resource owner. What is resource owner? A user or system that owns the protected resources and can grant access to them. I just give you the example, right? I have my phone and I am the sole owner of that particular phone because it's my phone, okay? And if you want to use it, I can grant you access and you have to ask for me. So that's the resource owner. Now the client. The client is the system that requires access to the protected resources. You, my friend, you are the client because you want to access my phone, right? So a client will need the access from the resource owner. And here you can see that client must hold the appropriate access token. If you want to access my phone, you need to have my password, right? So that is something that the access token will be given to you. So that's the resource owner and the client. Now the next is the authorization server. So this is the server receives requests from the client for access token and issues them upon the successful authentication and consent by the resource owner. So it's something very simple, right? Authorization server what it will do is it will just give you the token on behalf of the request that you are giving. Okay, authorization server is nothing but to authorize your request. It will just check that are you authorized to use that particular resources that you are trying to use, and once the consent for that is given by the owner, resource owner, then authorization server will allow you to use those particular resource. That's a simple thing. And the resource server, a server that protects users' resources and receives access request from the client. It accepts and validates the access token from the client and returns the appropriate resources to it. So it will just try to handle, or it will have all the resources. So it will try to handle all the resources, and if any of the request comes with the proper authorization, with the proper code, then it will allow the client to use those resources. Otherwise it will decline the request. So these are the terms, these are the main terms that we are going to implement. We will be implementing the authorization server, we are going to implement the resource server, and we are going to implement the client. So whatever the application that we are going to build, the APIs that we are going to build, that will be your client. So with that particular client, we will be implementing the authorization server and the resource server. So everything works together and your request will be authenticated. Now if you go back to the IntelliJ IDEA, if you see here, this is your Spring Security Client. This is your project where you have the different APIs, right? Whatever we have created. So these are the APIs that is your client, and this particular clients, whenever you are doing any requests, you might need the access from the authorization server or the resource server whenever you want to create any of the things. It's simple as that, right? So we have to create the authorization server, and all this authorization will be handled from your database. Okay, if you go to the database, these are the users that we have, right? Shabbir and Nikhil currently. So all your authorization will be validated against this particular users. We will be passing the user details. It will handle these user details, and once the users are validated, we will be allowing the resource to use. And the next thing that we have to understand is the scopes. Scopes are important concept because scopes exactly defines what you are allowed to use. Okay, suppose you are not the admin, so you are just the user, then you have only rights to read the data. If you are admin, you have some rights to modify the data as well. So all these particular things are defined based on the scopes of the application. Okay, scopes for the particular user, and all these particular scopes you will have to give the consent to use those particular scopes. So it's very simple. Like if you are going to any of the websites and there is a button to log in with Google, when you hit on that button log in with Google, you will be redirected back to the Google page, and where you will be entering your credentials. Once you enter the credentials, you are authenticated by Google, and after that you will be displayed the scopes. Like these are the permissions that your client is asking, right? To read your name, to read your email ID, to read your profile picture. These are the different scopes they have defined. So it's asking the consent from you that a particular client is asking all these particular details from me, and if you hit allow, then only the consent is accepted and the particular client is allowed to use those resources. It's similar thing. So these are scopes, and if you see this particular flow over here, so this is just the abstract flow. There are different particular variations available based on the different grant types, and the flow will be changed accordingly. So the ideal flow would be like you have the client, your application, your user, that is a resource owner, your authorization server, and your resource server, and this is your service APIs entirely on top of the authorization server and the resource server. Whenever application wants to use anything, application will create the authorization request to the user, to the resource owner, like I want to use this particular resources, and user will grant the access. Like you grant the access when you click on the Gmail, right? After login to the Gmail. So you gave the grant, like, okay, you can use those resources to the client. Now client got the consent, like, okay, I am allowed to use those resources. Then client will send that grant to the authorization server. Okay, I got the request. Okay, I got the permission now. Okay, this is the permission. So what authorization server will do is, okay, it will validate. Okay, you got the request, you got the code. Now take this token. So authorization server is giving token back based on the code that we got as the grant. Okay, so now the token is given back to the client after validation. Now with this particular token, the application or the client will hit the server to get the details. So once that particular token is valid, until that particular token is valid, so resource server will allow those requests. If the token is not valid, resource server will not allow those requests. It's a simple flow. This particular things you need to understand, that is the client, resource owner, resource server and the authorization server. This is how everything will work together. Now we'll go to the application and we will implement the authorization server, and we will connect our client with the authorization server, and we will also create the resource server. So if there is any resources that we have created behind the authorization server, then user can use those. So let's go to the IntelliJ IDEA. Okay, we have one client available, and this particular client has a controller, and you can see that there is one API get mapping/hello. So this particular request should be allowed only if you are logged in. Now let's implement the authorization server. So we need to create the new authorization server application. So let's do that. So now if you want to understand this flow, you can go to the OAuth playground. Okay, OAuth 2.0 playground, this one. Okay, and from here you can understand that particular flow. So here you can see that there are different flows available. There's a different types of implementation that you can do: authentication code, PXE, implicit, device code, OpenID Connect, and anything. Okay, generally authorization code or the OpenID Connect with PXE would be more implemented. So let's try to understand the simple authorization flow. I'll add the link in the description below so you can check this out. I'll go to the authorization flow, and here you can see that it is asking to register a client first. Okay, client means your API from where you're going to access. Okay, before you can begin the flow, you will need to register a client and create a user. Simple thing. So let's register a client. Okay, in order to use the OAuth API, you will need to first register application. If you go through this, right, if you go through this entire flow, you will get a much more understanding about the OAuth 2 flow. So I'll highly recommend you to go through this particular flow as well, so you will get more understanding. So let's register this client. Okay, and here you can see that you got the client registration data. So it's similar to how you will be registering your application to any of the OAuth 2 providers like Google, GitHub, LinkedIn, or whatever. Like whatever the OAuth 2 providers are there, you have to register your application and you will get the client ID, client secret. Let me just open this in a new window, and these are the client registration. So let me just continue and register this client to the OAuth 2. Okay, and here you can see that this is the first flow: build the authorization URL and redirect the user to the authorization server. And currently this way the authorization URL will be built. So your authorization server.com, whatever the authorization server is, /authorize. So /authorize this. So these are the standard APIs. Okay, these are the standard APIs from the OAuth 2.0. Wherever you will be implementing this will be the standard URLs. If you want to modify, you can modify, but these are the standards. And with this authorize, you will be passing more parameters. That is the response type. What type of response type it is? It's code. So because we have started with the authorization code flow, the response type is code. Okay, if for the different flow, this particular value would be different. And you can see the client ID, and client ID equals to client ID that we got, and the redirect URI. This redirect URI is nothing but once the authentication is done, where you want to redirect back. So that particular URI we need to define. And the scope. So these are the scopes that we talked about earlier, like what should be the scope of the access that you want to grant. So that scope, and this particular state. You can see that this state is the parameter. The client will need to store this to use in the next step. Okay, so this state also will be generated. So these are the standard parameters that will be generated to authorize your request. So let's authorize this request against the auth server, and here we need to add our credentials. So these are our credentials. So let me just copy the username, and this is the password. Okay, once we log in, it will be authorized. And here you can see that now it is asking for the consent. Okay, that do you approve or not. So we will approve. And here you can see that verify state parameter, and here you can see that it is checking that earlier state and the current state. After redirection, the states are same. If it matches, then continue. If it doesn't matches, then what is the flow? So you can check both the flows. So let's continue with the it matches, continue. So you can see that once this matches, the next is the exchange the authorization code. So after that, whatever the code we got, right, we need to hit this token URI to get the token. So here you can see that the grant type equals to authorization code. We are passing the client ID, we are passing the client secret. Okay, whatever the client secret it was, we are passing the redirect URI, and also we are passing the code. Okay, whatever the code we got from the above step. So once we hit on go, against this authorization code and all the details, we will get the token, and that is the token that we have to use. So once we click on go, at the end you can see that we got the token. This is the access token for your resources from your client. So you can see that there is a refresh token. The scope is also defined. What is the scope of this token? It's a barrier type. Okay, when it expires. So all this information is there. So you can try for the another flow as well, and you can check it out how everything is working. So this is a general idea how this auth 2 will work, and similarly we will be implementing in our system. So now let's go to the Spring initializer. Okay, start.spring.io, and let's create the authorization server. So let me just add the group ID com.daily code buffer, and the artifact I'll give is auth authorization server. The package name I'll give auth server. Okay, packaging is jar, Java version is 11, and let's add the dependencies. So I'll add the Lombok dependency, I'll add the JPA dependency as we need to connect to the database, I'll add the MySQL driver, I'll add the security, and I'll add the web dependency. So these are the dependencies that I'm adding in my authorization server. So let's generate the project and add in the IntelliJ IDEA. So I'm just generating the project. Let's open in the Finder, unzip it. Let's copy this, go to documents, Java workspace, Spring security, and I'm adding over here. Okay, now this should be added to the IntelliJ IDEA. And if I go to my parent, that is Spring security tutorial, let me add the module auth 2 authorization server. Okay, here you can see that auth authorization server is imported. I'll be using the services. Now within this authorization server, okay, we need to add one more dependency, that is the authorization server. So let me just go down over here in the dependency section. Let me add the dependency, that is the Spring security auth 2 authorization server. The version that we are using is 0.2.2. So this will allow us to create the authorization server. Now for this authorization server, let's go to the Java main resources. Let's change the properties files to YAML, and let's change the server port, server.port to 9000. Okay, so I'm just changing the port, and for this, as we are going to use the JPA with the same database, I need to add the configuration details for the same. So let me just go to the Spring security client. I'll go to the resources application.yaml. Let me copy this detail, and let me go to application.yaml and paste this. Simple, right? I'm just using the same MySQL localhost 3306 user registration schema. Username password is root, class name provided, and show SQL is equal to true. So all these details are there. Now for this particular authorization server as well, we need to use this user registration and the user flow, right? So we need to have the user entity, user repository, and the user services that we have defined in the Spring security client to my authorization server as well. Ideally, if there is any duplicate files that you have to use, so you can separate out all those particular files in a separate project, and you can use that particular project's dependency in your pom.xml file. You can go ahead that way also, but currently let's directly use those. So in my Java folder, let me create the packages. I'll create the package entity, service, repository, config. So I need the user entity, so let me just copy this and paste it over here. Then I need the user repository, so let me just copy user repository and paste in the user repository. Now in your auth authorization server, we need to implement the custom user detail service. Now user detail service is the default service provided for the users to interact with the Spring security to check if the user exists or not. So that particular thing we have to customize it to use our database. So we need to create the custom user detail service for that. So let me just create a class that says custom user details service. Custom user detail service, this is the class in the auth authorization server, and this is the service, and we will implement this as a transactional. And this particular custom user detail service will implement user details service. This user details service, you can see that is part of the Spring Security. Okay, and there is a method that we need to implement, that is the load user by username. So whatever the username is, for me the username would be my email ID, whatever that we are using. So with the help of the user ID that we have, we need to load the user from the database, and we need to pass back to the Spring Security. So Spring Security can handle that user. This is very important step, okay? Because without implementing this user detail service, Spring Security will not know about the users that we have in the database. So for this reason only, we had added the user and user repository, entity and repository in our application, copied from the client. So let me just create the object of user repository, and I'll auto wire it. Okay, now instead of username, I'll just make it as email so we can understand better. So here let's implement it. We need the user object, that is the what we have added in the entity. Okay, so let me just use this daily code buffer auth server dot entity. This user equals to user repository dot find by email. We'll pass the email. Okay, we got the user. Then we will check if user equals to null, then throw new user not found exception, and you can pass no user found. And after that, if so, and now we need to return the user. That user would be of this one, that is the org.springframework.security.core.user details. So this is the user that we need to return back. Okay, and here this particular user needs few details. So let's pass it user dot get email, then user dot get password. Currently I'm passing everything to true, because if you see this, we need to pass username, password, it's enabled, account non-expired, credentials non-expired, account non-locked. So 1 2 3 4 true. This value I can get from the user itself. So user dot is enabled, rest everything to true. Okay, and the last thing it requires is the authorities. Authorities is nothing in the Spring Security, that what all things that you are authorized to use the resources. It's just as the scopes. Okay, so let's implement the method for that as well. So I'll just implement get authorities method, and here in this authorities I'll pass the list dot of user dot get roles, and this get authorities, let me just create this method, and this is a collection that extends granted authority. Now we need to create this granted authorities. So let me just create the list of granted authorities. Authorities equals to new array list, and for each string role in roles. Okay, let me just rename to roles. I will need to add the authorities. So authorities dot add a new simple granted authority, si simple granted authority, and I need to pass the role, then return authorities. Okay, so let me just add the new over here. Cool, right? You can see that I thought that we did a lot of things, but it's simple. We just created the custom user detail service and implemented the user detail service, which is very important part of the Spring Security to load the user based on our database. That's the custom implementation. So we injected the user repository, and this is the load user by username method that we have implemented the method which is taking the email as the input parameter. We got the user from the database. If user is null, then user is not found, exception we thrown. Else we created the user object from this user that we have from the database. So we passed all these details, email, password, enabled everything. Okay, all these details you can pass from the user. You can add all these details in the database. Okay, and we can handle it. And we got the roles, and based on the roles we created the authorities. Okay, so the user is created. So now this particular user will be part of the Spring Security. So whenever we need a user, we'll get directly from you. So your custom user detail service is done. Now comes the other thing, that we need to implement the configuration. We need to add the configuration for our authorization server. So this implementation would be standard for all the authorization servers. So there is a bunch of code where you will be creating the public keys, private keys, and all those stuffs to handle your authorization server, so your clients can connect to it and the exchange between the authorization code and the token can be happen smoothly. So it's a bunch of standard codes that I'm going to add over here, and I'll try to explain it. So for that, let me create the configuration file. So in the config directory, config package, I'll create the Java class and I'll say authorization server config. Okay, so this configuration would be basically standard configuration for your authorization server. I'll just add the configuration and I'll just add proxy bean methods to false. Now there are a bunch of standard implementation that we have to do. So let's add that. We would be needing the password encoder. So I'm just adding the password encoder over here. So now you can see that the bean is not available. So we need to create the bean for it. So let's create the bean for it. So let me go to the custom user detail service itself, and here let me just create the bean. Okay, I'll just use password encoder. I'll just make it a public method. And return new bcrypt password encoder with strength 11, the same thing that we have added in our client as well, and annotate with bean. No fancy stuff. Okay, so now in the authorization server, there it is gone. Now let's add bunch more things. Now we need to add the security filter chain. Okay, so let me just create the bean of it. So here you can see that we have implementing the security filter over here, and we are injecting the HTTP security. So what we want to do for our security, so it's simple stuff. This particular thing, you can see that the auth to authorization server configuration dot apply default security. So we are applying the default security over here. That means that default auth to authorization functionality. So default / authorize API / token API, all those default APIs are there, right? For the auth to, all those default APIs will be defaultly added to our configuration. So that's what we have done over here for our security filter chain. Okay, if you go to this particular class, you can see that this is the apply default security that we are calling, and these are the bunch of default configuration is being added over here. Okay, you can see that all the RSA keys and JWT encoder and everything is been defaultly added over here, and we are calling that apply default security. So all those particular APIs are available for auth to, all those default APIs will be enabled. And then what we are doing for this HTTP, we are using the form login, and we are customizing this form login for the default. So with the default configuration for auth to, everything will be set up with this line of code. Okay, and we have added the highest precedence for this bean to be used. So if you want to configure any of the APIs for the auth to, then this is the place that you have to configure. But I'm going with the defaults. You should go with the defaults unless there is a specific requirement. Okay, so this is the configuration for that. Now, as we saw earlier, every time the clients were getting registered to the authorization server, so here also we need to register the clients. So client registration also we need to enable over here. We need to add the configuration for it. So let me just add the default basic configuration. I'm just copying this code because this is the standard code. Okay, now there is a lot of things in this method, but don't worry, everything is simple. So here you can see that it is registered client repository. So this is the repository that has been provided for all the clients to get registered. Okay, so if you want your custom implementation, you just have to implement this interface. Okay, it has the couple of methods, that is the save find by ID, find by client ID. That's it. You just need to implement these methods according to your requirement, according to the database that you're using, or according to any of the things that you're using. If you just implement these three methods to get the particular output or particular return type, that's all good. Okay, so currently I have only one client available. Okay, I am using only one client, that is my Spring Security client. This particular Spring Security client I want to register with my authorization server. So that's why I have just added one client statically over here. Ideally you won't be doing this. These are the static configuration. Okay, if you want to do dynamically, like how we saw earlier, you need to use the JDBC registration client or your custom registration client, where you will be getting all those details, or you will be generating all those details and giving to the user who wants to use your authorization server. I know what I want to use because this is my project, this is my client, and for this client there are details that I am using over here, that I am registering over here, and these details I will give to this client. So this client can connect to the authorization server that I have. Okay, so this is simple thing. I am creating the object of registered client with random UUID. Okay, and what I am giving this details, that is the client ID. I'm passing the client ID as the API client, that is the name of my client. So my Spring Security client, this is the name I'll be giving to this Spring Security client. Then I'm giving the client password, that is the client secret. I am encoding the password with the secret. Then client authentication method. So I'm using the client authentication method as the client secret basic. Okay, so whatever the secret information that I am passing over here, with that particular information I'll be able to authenticate my client. These are the grant types that we are allowing. You can see the authorization code, password, refresh tokens. So these are all we are allowing for the client to access through. Then these are the redirect URLs. I will talk about these redirect URLs later. So these are the URLs of your client. So once the authentication or once the authorization is happened from the authorization server, where you want to redirect back. So I want to redirect back to this particular URLs. Now how I got this particular URLs, that I'll tell you like how we got this. These are the standard format URLs that you can define. Okay, so everything I'll tell you later once we implement this, but consider these are the two URLs, redirect URLs. Then I have defined two scopes. Okay, one scope is the OIDC scopes for your OpenID Connect, because we are authenticating as well, and the other scope is read scope, API.read. And then the client settings I have extra added. So what I'm doing is, in the client setting is client settings.builder.require authorization consent. So I am enabling the consent over here, that my authorization server, this server needs to give the consent back to the client to allow. Okay, so it will have the page of the consent as well. If I don't add it, there won't be consent, the consent will be directly given. And I'm building this particular object. Okay, and I'm using the in-memory registered client repository. So this particular registered client will be in the in-memory itself of this particular authorization server. There is one more default implementation added, that is the JDBC registered client repository. If you want, you can directly use that as well, and if you want, you can create your custom implementation as well. As far as I know, there will be only these two implementation by default provided by the Spring Auth server, because there are a lot of databases and there are a lot of implementations available. So you can always go ahead and implement according to your requirement. If you want to use Mongo, Redis, whatever, Cassandra, whatever you want to use, you can implement this particular repository. You can implement this repository according to the database that you are using to register your clients. I have one, so this is direct. So this is a code to register my client. We'll come back for these two redirect URLs later. Okay, but rest of the things are clear, that we are giving the authorizations and everything. So how to connect my client to this authorization server. Then now the next thing I required is the public and private key configuration. So let's add the code for that. Okay, here you can see that I've just added this information, but this is nothing but the standard configuration for your public private keys. We just have to create one bean for the JWK source, and we're just creating the RSA key over here. This is the standard. You just need to copy paste it and it will work. You don't have to change anything. Okay, until and unless you have to change the algorithm, like which algorithm that you are using to generate the key. That's it. Rest everything you can directly use it. Now you might be wondering from where I got this code. Got this code from the samples shared by the Spring Security team itself. You go to that repository Spring Security auth server, all these particular details are there, so you can directly use from there. This is nothing fancy, just directly use it. You don't have to change anything, you don't have to bother about it. Okay, now the next configuration that you have to do is the provider settings. So provider settings is nothing but the authentication or your authorization provider, auth server provider. So these are the bean configuration for that. So here you can see that I have just defined a bean for the provider settings. Okay, you can see that there are a lot of information, a lot of changes that you can do. We have just defined the issuer. You can change the authorization endpoint, token endpoint, JWK set endpoint. So if you want to configure any of the endpoints over here, you can configure the endpoints. Okay, but by default, the standard endpoints you will get. These are the beans that I have provided. Now you can see that the issuer I have provided is HTTP auth server :9000. So if you see 9000, that is the 9000 port of my auth server itself. If you go to the application.yaml, this is my auth server currently, and I have passed the URL for that. So now this particular auth server URL you can define in your host files. Okay, so what you can do is you can go to the terminal, and if you go to cat/private etc host file, okay, and here you can see that this is the host file that if you want, you can change this host file. And here you can see that by default the local host for 127.0.0.1 would be there, and I added one more entry for the host as the auth server over here. That's the only thing that I have implemented. So this is the configuration that you have to add for your auth server to work with that particular URL. So I hope this is clear now. So the configuration for the authorization server is done. Now we need to do the configuration for the basic Spring Security as well for this. So let's add the default Spring Security configuration. So let me just add one more configuration file, and I'll just say default security config. Now you might be wondering, there are a lot of changes and a lot of complex things here, but don't worry, these are very simple, and this you have to do only once. Once this is done, once this is set up, you are good to go always. So this is the default security config, and we need to enable web security, and here I am just adding the configuration. Simple. Okay, if you see here, I'm just adding again the security filter chain, and I'm getting the HTTP as the input parameter. What I'm doing, I'm just changing the authorize request. So I'm just doing that all the request coming here has to be authenticated. Okay, any request has to be authenticated with default form login for the authorization server. That's it. Okay, simple thing. Now a lot of configurations are done for the auth server, very little things are left. So now we have defined the custom user detail service. Like this is the user detail service that you have to use to validate the user. We define the authorization server config, like how the authorization server should work. We also defined how your basic security should work, like all the requests should be validated. So now one thing is left is your authentication provider, like authentication manager, how you should be managing your authentication. So whatever the user object from the custom user detail service I created right from here, now with this particular details, with this user that I have created, I need to validate the credentials that I'm providing from the input. So whatever the input that I'm providing, that has to be validated against this users, right? Whatever the users that I have mentioned. So I need to define the custom authentication provider as well, so that the users are validated against. So let me just create the configuration for that. So let me just create the service, and I'll just say custom authentication provider. I'll annotate this with service, and this custom authentication provider will implement authentication provider. Okay, and we need to implement the method as well, that is the authenticate. Okay, these are the implementations that we have to provide. Now how we can authenticate, we need the custom user details service as well. So whatever we have defined over here, so let me just inject that private custom user details service. I'll just auto wire it, and I'll also need the password encoder over here. So let me just auto wire it, private password encoder. and now this is the authenticate method in which we have to customize it. Okay, so let's do this. So let's get the username password, string username equals to, I'll get authentication dot get name, string password equals to authentication dot get credentials dot toString. Now user details object we need from the security. User details equals to custom user details service dot load user by username, and here we need to pass email. So email is your username. We'll get the object of the user details. Let me just make it to user, that is better. Now we need to validate the user. So let me just create the method check password, where you are passing the user and password. Okay, and let's create this method, and this is your raw password. Okay, let's implement this if, let me rename. Okay, check password. I don't know why I make this much spelling mistakes. Okay, now if password encoder dot matches raw password with user dot get password, return new username password authentication token. Okay, where we need to pass user dot get username, user dot get password, and user dot get authorities, else return new bad credentials exception. Let's say bad credentials. Okay, throw. Simple. So here you can see that we are just authenticating, okay, with the authentication manager over here, and we need to add the support as well. So let me add this, return username password authentication token dot class dot is assignable form authentication. Okay, so this authentication has been handled over here. So you can see that simple thing, authentication is handled. Now this custom authentication provider we need to bind. Okay, so let's do that. So let me go to the default security and let's bind this over here. Let me create the object, private custom authentication provider. Okay, I'll auto wire it, and let me create the bean of authentication manager, public void bind authentication provider, auto wire it, and I'm just injecting authentication manager builder auth, and this authentication manager builder dot, what is the authentication provider? That's the custom authentication provider. Okay, so we just bind this custom authentication provider to our authentication manager builder. That's it. You can see it's simple, looks difficult but simple. So now your authorization server is ready. All the configurations are done. It can handle all the requests. Now we have enabled everything. Now we need to register our client. We need to add the configurations in our client to talk to this authorization server. Okay, as every authorization server will give you the details to handle everything in your system, we need to do that. So if you go to this authorization server config, you can see that these are the register client repositories. These are the details that we need to handle. So this is our Spring Security client. Here we need to handle everything in our application.yaml. Currently we have the Spring data source on JPA. Now we need to add for the Spring Security auth. So let's add that. I'll just copy the details and I will explain you everything. If I type, there will be some error in the indentation and we might waste a lot of time. So let me just copy the details. After the DDL auto update, I'm just copying every details over here. Okay, so now you can see that it's part of Spring Security auth 2 and we are adding the client. Now after this client, these are the custom things now we need to handle. Custom is registration. So this is the name of your client. Okay, we are adding the registration client and the name is API client OIDC. Okay, provider is Spring, Now this Spring provider I will get into details. The client ID and secret, that is the API client and secret. This is the same thing that we have defined over here, that is the API client and secret. Okay, API client and secret, that is the API client OIDC. Authorization grant type is authorization code. This authorization code we have enabled. You can see that authorization code we have enabled, grant type. Then redirect URI. Now this redirect URI is standard. HTTP, your server name, your port, /login, /auth2, /code and registration ID. Your registration ID is nothing but your API client OIDC. Okay, and the same URI, whatever it is configured over here, the standard format you can see over here. Okay, HTTP 1270.0.1 8080 login auth2 code and API client OIDC. That is the client over here that you have defined. Makes sense, right? Now the scope is OpenID for your authentication, as we have implemented, as we have added the OpenID as well, and the client name API client OIDC. And now the below one you can see it's for the API client authorization code, where the provider details, client ID and the client secret we have mentioned the same. Authorization grant type is authorization code and the redirect URI is 127.0.1/8080/authorize. Once authorized, this is the redirect API it will be redirected to. Okay, and the scope we have defined is API.read. So this is the scope that we are going to define, and the same thing we have defined you can see in the authorization server config. You can see that API.read scope, and the other one was OIDC scope.openid. The same thing we have defined over here, that is the OpenID scope. And the provider, you can see the provider Spring Issuer URL, it's http:/auth server 9000. If you come back over here, you can see that we have defined the issuer over here, that is the auth server 9000. So the same configuration we have defined over here. Similarly, you can define according to the name that you have given over here. So this is the name, according to the name, everything you have to provide over here. So if you come, you can see these are the two redirect URL you have mentioned over here that only you have configured. Okay, and this redirect URL is nothing but the standard format that you have to give based on the client ID or the client name that you are giving, registration ID. So this is the configuration. Now the next thing you need to configure is your web security. So if you go to the config, we have created the web security config. Here we have enabled the web security and we have added the security filter change, where for the HTTP we are disabling the CORS and CSRF, and we are adding the authorized HTTP request, and we are permitting all the URLs. This all the URLs we are permitting, but other than that, what all the other URLs we have to be authenticated to go into that. Okay, so let's add that. So I'm adding one more, ent matchers /API /anything coming with /API /anything has to be authenticated. Okay, and we need to add the configuration for our auth server as well. Now .auth2 login we need to add. Now for this to work, we need to add the authorization client as a dependency. So let's add the dependency. So I'll go to the Spring security client and I'll go to the pom.xml file and I'm adding one dependency. And this dependency you can see is for Spring Boot Starter auth2 client. So this will be my auth2 client now. So now if I go back to the web security config, I'll be able to add. Let me stop the server and invalidate the cache so everything is refreshing. So I'll give the auth2 login and auth2 login. And we need to give the login page, which login page to redirect. So we can define auth2.login page and we need to pass the URL. So the standard URL we need to pass, that is /auth2/authorization/ your registration ID. So whatever the registration ID that you have defined, right? If you go to your application.yaml, that is the API client OIDC. So you will be giving API client OIDC, your login page. .auth2 client customizer with defaults. Okay, with default configuration we are enabling everything. That's it. So this is the configuration that we need to add. Now /API, right? So if you go to the hello controller, so let me just add the /API /hello over here. Okay, so this is the API that we are going to call, and it is just returning hello, welcome to Daily Code Buffer. Okay, so let me just start the auth server. So your auth server is started, and let me start the client as well. So I started the client as well. Okay, now you can see that it's connected. Let me just go to the browser. Okay, now let's go to the localhost. Let me just open the debugging tool. I'll go to the networks. Let me just close this. Okay, and let me go to the localhost 8080 /API /hello. For this, my request should be redirected to the authorization server for authentication. Okay, and here you can see that it has been redirected. Okay, now here I need to provide the authentication. Here you can see that it is redirected to the auth server colon 9000/login page, and here you can see that your hello controller was there, right? Your hello API, it was called and it was sent to the API YDC. This is a URL. You can see that auth2/authorization/API client YDC, and you can see that the authorize was called with the response type, client ID, so scope information, state information, redirect URI, everything is passed. The same flow that we have seen with the playground, right? That these are the API, these are the endpoints will be called. Okay, and after that it's been called the authorize. So we need to get authorized. So what I'll do, I will add the details. So if I add any details, okay, and if I try to sign in, you can see that no user found. So this is the particular flow that will happening. So it has to be authenticated. Okay, now if I give the correct information, if I go to the MySQL, okay, if I get the Nikhil over here, okay, if I pass nikhil@gmail.com, and the password for that we had kept was 789. Okay, so if I go back to the browser, okay, if I do 789 and if I sign in, you can see that it has been redirected back. Okay, if I go to the /API /hello, you can see that I'm getting the proper response now. Okay, hello, welcome to Daily Code Buffer. Now if I want to get the logged in user information, that also I can get using the principal. So let me just add that as well. So if I go to the controller, hello controller, and here if I inject the principal object, principal from the java.security, and here I'll just say hello, and I'll just define principal.getName. Let me restart my client. Okay, my client is restarted. Now let's go to the browser. Let me just open the incognito mode, and I'll just do localhost 8080 /API /hello. Okay, you can see that I am redirected back to the login page, and if I give the proper information, let me just copy the email ID. Okay, and I'll give the password 789, and if I click on sign in, you can see that I'm redirected back. I'm getting this error because I have not defined this particular endpoint, but instead of this, if I go back to API /user, hello, you can see that I'll get the user as well, that nikhil@gmail.com is signed in. Okay, and as I have defined everywhere as 127.0.0.1 instead of localhost, if I hit this URL instead of localhost, okay, let me just close this. Let me just open the incognito again, and if I hit this, I'll get the login page. Let me just give the Nikhil information over here. And if I do 789, then it should redirect to the correct page. You can see that I'm getting the correct page now, right? It's been redirected correctly. So this way you can see that we have implemented the auth2 with OpenID authorization server and the client as well, so both of them can interact with each other and only the authorized resources are allowed. Now what if you have a resource server as well? So your resource server is there where only the authenticated user can access those authenticated resources, and if you want to access those resources using your client, how to handle that? So let's create the resource server. Let's create one more application, add into our project, and let's go around how to fetch the data from the resource server as well. So let's try to do that. Let me just close this. Let me go to the start.spring.io. I'll just do com.dailycodebuffer, artifact as auth resource server, packaging as jar, Java version as 11. Okay, and here what I'll do, I'll just add the web dependency, I'll add the Spring Security dependency, and I'll add the auth resource server dependency. Okay, that's it. Let's generate the project and add in IntelliJ IDEA. So yeah, let's generate it. Open in Finder, unzip it. Let's copy this. Okay, let's go to IntelliJ IDEA and add as a module in our main project. Let's go to pom.xml file. I'll add the auth resource server and maven reload projects. Here you can see that this is the auth server. Now let's configure the auth resource server as well. So what I'll do, I'll just first change the application.properties to application.yaml, and I'll just do server.port as 8090, and I'll add the configuration for the Spring Security as well. So what I'm adding, I'm just adding spring.security.auth2. This is a resource server, JWT, issuer URL is auth server 9000. So this is my issuer URL. So I just configure this as a resource server. Now we need to handle the basic Spring Security as well. So let's go ahead and do that. So here with the Java, let me just create the new package, and I'll just say this is a config package. And within this config package, let me just create the Java class, and I'll just say resource server config, and I'll enable the web security. Here we need to create the security filter chain bin. So I'll just define security filter chain, and this is a bean. Now you might have noticed that we have everywhere in all the application we have defined the security filter chain. Okay, and I'll just define the HTTP security. Now we need to configure this as the same way we have configured in our auth server and the client as well. So we'll just define http.mvc matchers. Now all the API request, okay, we are targeting, and it should be authorized request .mvc matchers /API/ all the API request, and here we need to add the exception. Okay, let's add the exception dot access. We need to provide the access, and it should have the access only. So here you can see that we are calling the method that access only has authority API read. So here you can see that we have defined the scope. Okay, so whenever we are defining the scope for the authority, we need to define as scope underscore and whatever the scope it is. So we are just handling the API read now. If there is multiple, we can add the multiple access over here. So this is the API read that we are defining. Dot and auth2 resource server, auth2 is a resource server dot JWT. Okay, and we need to return http dot build. Simple. So here you can see that simply we just define the security filter chain where we are authorizing all the requests where scope is API.read. Now let's create the resource or the API for this resource server. Okay, so what I'll do, I'll just create one package, and here I'll just say controller. Inside this controller, let me just create one Java class, and I'll just say user controller, annotate with REST controller. Okay, and let me create one method, public string of array get users, return new string, and here I am defining multiple users. Okay, let me just define Shabir, Nikhil, Shivam, and let me annotate with @get mapping /API/users. Okay, you can see that the simple API that we have created. Now suppose this is the API provider, this is the resource server. Okay, and now in your client you want to call this API, but it has to be authenticated, right? It has to be within this scope, whatever the scope we have defined. If you're passing the scope and it's matching with the scope, then only we should be able to get the details. So we need to configure our client to handle the web client. So we'll be using the web client to call this particular URL and to fetch the data. So we need to configure our web client as well. So let's go ahead and do that. If you go to our Spring Security client, and in the pom.xml file, we need to add the dependency of the reactive Spring, as we are going to use the web client. Now this is nothing but you are calling one of the APIs that is behind the authorization server, that is your resource server. You want to call those resources, you want to utilize those resources. To utilize those resources, your web client has to go around, get authenticated, and should get you the data. That's it, right? It's simple as that. Whatever the API that you are directly calling from the client, and if you want to call another API from the another resource server, it has to be authenticated, it has to be within the scopes that you have mentioned, then only you should get the details. So that's what we are trying to implement. So let's add the dependency for that. So let me go to the file over here within the dependency after the auth2 client. I am adding 2 more dependencies, and you can see that it's a Spring Web Flux dependency and Reactive Native dependency. So we can use the web client. So now as we are going to use the web client, we need to configure it as well. So let's go ahead and configure it. We will create the configuration class for that. Now this all things, you can see whatever configuration I'm adding, that is only one-time configuration. So the only challenging thing to understand is that configuration part in the starting. But once you add the configuration, once you get the hang around of it, it's very easy to implement the other things. So as I need to configure the web client, I'll create a new class that says web client configuration. Okay, and I'll annotate with @configuration. Okay, now there is a default configuration. Okay, you can directly add the configuration, so I'll just add the configuration so you can directly utilize it. So here you can see that I've just added the configuration. Let me import all the classes. So okay, I'm sorry, I just added the web client configuration at the wrong place. So let me just delete from here, or let me just Ctrl+X from here. Go to the src in Spring client, in Java config. Here I need to add. Okay, and from the pom.xml file, let me just correct it out if I have done any mistake. No, it's all good. In this pom only I have added. Okay, make sure that if you are working with multiple projects, this type of things happens, this type of issue happens. So make sure that you are adding at the correct place. So you can see that it's just a filter function added, and it's applied that web client will be auth2 client to configure. Okay, auth2 is configured to use. And here you can see that this is the authorization client manager, where it is using the authorization code refresh token and all those things. So this is just a default. You can see it's just a default implementation. You just copy all these details, you just enable the beans web client and auth2 authorization client manager, and you're good to go. You don't have to do anything. Now once this is implemented, we can use web client to call that particular API that we have added in the web, in our resource server. Okay, so let's do that. So let's go to the controller, let's go to the hello controller, and here we can call that API. So let's do that. So right here I am creating one method that is public string of users, okay, and you can see I'm just passing as a get mapping and /API/users. and here we need to inject auth to authorization client. Okay, and which authorization we need to annotate with registered auth to authorization client. Okay, so we need to bind it. So which particular, so if you go to the client, okay, if you go to the resources application.yaml, this is the one, API client authorization code. This is the one that directly we are binding, that it will be using the API client as the client ID, secret, the authorization code, the URL, the scope, all this information for our authentication for our resource server. Okay, so let's go over here and let's define this, that this is the one that we are going to use. Hope so now it is visible. Now we need to use the web client to call that. So let me just auto wire the web client as well. So I'll just do private web client and I'll auto wire it. Now return this dot web client dot get dot URI. So we need to pass the URI. So what would be the URI? This one, http 127.0.0.1:8090. That is the port number that we have defined in our resource server, and /API/user is what we have defined as the endpoint to get the resources. Okay, and then we'll define dot attributes auth to authorized client. Okay, so in the attributes that you have to define is server auth to authorized client exchange filter function. Okay, this is what, if you go to the web client, this is what you have defined, right? So that one we have defined, and let me just do the static import, and here we'll define the client dot retrieve dot body to mono. This is of string array dot class dot block. Okay, so the error I'm getting is because of the attributes. It should be attributes. Okay, it's simple thing. Okay, now this particular method is ready. It is trying to get the data from the resource server that we have defined, and after authorizing, I am getting the data. So now let's start the server. I'll start the auth server first, then let me start the resource server as well. I'm sorry, the resource server only started. Let me start the auth server as well, Spring client as well. Okay, so here you can see that everything is started. Now if I want to call the hello controller /API/users, it will try to call this particular resource server that is behind the authorization server as well. After authenticating with the proper scopes only, I'll get the resources. So let me just go to the browser. Let me open the incognito window. I'll just use this /API/hello. Instead of that, I'll just define users. Okay, it should be redirected to the login page as it was intended. Then I'll give the user information and password is 789. And here you can see that it is asking for the consent from the resource server that you should be authenticated. You can see that API client. What is the API client? API client is nothing but your client. If you go to the application.yaml API client, this is your client, right? And what it is asking, you can see that it wants to access your account, that is this one, nikhil@gmail.com. The following permissions are requested. What is it? Scope only we have defined API read. So we'll just give the API read consent and submit the consent. And you can see that I'm getting the data over here. So you can see that my resource server is behind the authorization server. Once the consents are there, after that only I'll be able to access those resources. So that's how the complete flow with the auth to an OpenID for authorization server, resource server, and the auth client works. So if you want to understand more in depth about everything, I'll add the documentation link in the description below so you can check that out. I'll also link the different articles where I have read about it. I'll link everything in the description below so you can check that out. And there are different flows as well. Like we just use the authorization code flow. There are different flows also available, so you can try and implement those flows as well. But the fundamentals are same. Just focus on the fundamentals just try to understand everything and learn accordingly. Ideally, there will be very less chances where you will get to implement all this kind of securities, because nowadays there are a lot of third-party tools available like Okta, Auth0, like Gmail, GitHub and everything, right? So most of the times people will be using that only, and it is suggested to use it because they have done a lot of work on that. The tools are really good, so we can directly, without worrying everything, we can directly get all those security features. And I'm also not a security expert by any means, but this is what I have understood and I've implemented. And this is also not a particular flow that you will be implementing in the production. There are a lot more extra features, there are a lot more extra configurations that you have to do within this as well to make your application more secure. So these are all the details that I wanted to share about the auth server, resource server and client and everything. If you have any doubts, then do let me know in the comment section below. And if you want to learn more about how to package those applications and to deploy to Kubernetes and to learn Kubernetes, then these are the videos, and you can check out these videos to learn more about the Kubernetes and how to deploy these services to the Kubernetes cluster, and also how to automate those deployments as well. So that's all I have to share. If you have any doubts or anything, then as always, do let me know in the comment section below. I'll try to help you out as soon as possible. So I hope you have enjoyed this tutorial. I know it was very long and it was a complex as well, but I have made my best effort to make it as simple as possible. So hope you enjoyed it. And if you like this video, give us a thumbs up and subscribe to the channel for the upcoming awesome videos. If you want, you can join this channel as well and support me. So that's all in this video. I'll see you in the next video. Till then, happy coding. Bye bye.